Hello everybody, how is everything? How are you all good? So this is our second boards class. I mean, like the classes we are doing for board exams, and this is the second day of that. Yesterday we did relation functions, we revised ITF, and I hope you are practicing along. If not, then marks will matter, marks will be affected. So I think voice and everything is okay. Let me just check. And I hope I'm sure that today very few would be watching. Only serious people, serious students will watch, or non-cricket fans would be watching my session. Otherwise, everybody would be just watching Kohli and Rohit Sharma. Huh? India's batting is about to come. 264 is not a bad target. But yeah, studies are studies. Work is work. We'll win. Definitely, we should watch. As a cricket fan, even I would want to watch this match of Australia and India, the most crispiest match. But there are exams, guys. Right? We have exams. So that is something which should be more serious for us, which should be more important for us right now. Algebra, second day we are going at, and the chapter which we are, is my voice clear? Just can somebody reply if you're there? Please tell me if my voice is clear. Let me check. Yeah, I think voice is okay. So algebra, yes, thank you Abhishek, thank you. All right, algebra means matrices and determinants. Okay, algebra stands for, in class 12th, the topics which come under algebra, arithmetical or general algebra would be matrices, matrix and determinants. This chapter is calculative. These chapters, actually these are two different chapters. Combinedly they are called matrices, matrix and determinants. Calculative chapters, but yeah, very scoring. 10 marks question would come from this. 1 5-mark question can come, 2-mark question can come, 3-mark question can come, or 2 objective type questions. Generally we have seen the pattern. Last year also there were 2 objective type questions, so 2 marks were from there. 5-mark question was there, and there was a 3-mark question also from matrix and determinants, combinedly from matrix and determinants. Okay, after this 30 marks will be for calculus, which we will be doing tomorrow. But major marks, major scoring, this chapter is going to give us, and very easy chapter. It's just calculative. You just have to learn how to solve. Very easy chapter. You just need to take care of a few things. So we'll not waste time. We'll start. Before starting, one more thing for JEE aspirants. If you are preparing seriously for 2026 attempt or even 2025 JEE advanced and the main second attempt, then you should join one of these batches. If you are in class 11th right now, join Nimbus batch. If you are in class 12th right now, join Nexus batch, which is going to prepare you for the second attempt as well as advanced. And if you are a dropper and going to be appearing in 26, right, even class 12 students, if you have just now entered class 12 and you are going to appear in 26, then also these are very good options, and I'll tell you why these are good options. I'm not I know that obviously this is a part of the job that you have to tell about these, but these are actually good. I'll tell you why. What is the USP over here? USP of these batches will be the DPP. If nobody will give you the practice problem for such a good price. For 4,500, no, you can't even get a good amount of practicing or good level of practicing. You can't buy that. So if not for learning also, even if For DPP, if I go, this price is amazing, and along with that you're going to have doubt solving, AI assistant, teachers are going to be there, all round doubt solving is there, many things are there. So I think these are good choices, and this offer is valid till 9th March. That's why we are telling you again and again about this. Now let's start with matrix and determinants. Matrix is a box which is well defined. In this box, things are kept in an order. The order is called M into N, or we also can call it R into C. That means row multiplied with column. M represents the row and N represents the column. Simple thing. So if I want to make a 3 cross 2 matrix, it will have 3 rows and it will have 2 columns. Right, that is the definition of matrix. It's just a box of elements. Now 3 rows, that means A11 is element in the first row and first column. A12 is the element in the first row and second column. A13 will be the element in first row and third column, and it will go on like this. Now the other things, okay, A21 means second row, first column. 22 means second row, second column, second row, third column. So this is how it is going to go, like this. This is mth row, first column, mth row, second column, mth row, nth column, right? So m cross n is the order of this. That means there are m rows and n columns in this matrix. Simply, if I want to just add some elements, suppose I have a box and I want to I'm adding 1 2 3 4 5 6 7 8 9 10 11 and 12. So how many rows are there? 1 2 3 and 4 rows are there. How many columns are there? 1 2 3. Columns mean vertical, rows means horizontal. So 4 cross 3. We have recently studied this chapter, but today we'll be studying specifically for board exams. We are going to prepare this chapter for our board exams. So let's start with it. Okay. So this is how we define a matrix. Suppose if I want to make a matrix like this, 1 2 3 4. How many rows are there? How many horizontally? How many rows are there? 1 2 3 4. 4 rows are there. How many columns? Just 1 column. So this is just 4 cross 1. Okay. This I can call as 4 cross 1. Hi Siya Sakti, Siva Sakti. Alright. Okay. Now suppose if I make this horizontally, 1 2 3 4 5. How many rows are there? Horizontally just 1 row is there. How many columns are there? This is column. All verticals are column. 1 2 3 4 5. Vertically it is 5 columns. So what will I write? 1 cross 5 will be the order of my matrix. 1 cross 5 will be the order of my matrix. This will be 4 cross 1. This will be 4 cross 3. Simple, most good looking matrix is an m cross m, or we also call it as a square matrix. So if we write 1 2 3 4 5 6 7 8 9. Square matrix means in which we have same number of rows and columns. For example, over here 3 cross 3, 2 cross 2, 1 cross 1. Okay, 1 cross 1. So if I enclose number 1 or any number inside this, let's say 5 6 7, any number, this is also a matrix. If I name this matrix as A, the order of A is 1 cross 1. 1 cross 1 can also be an order. Now after this we'll see some types of matrix, because on this basis questions are asked. So I'll quickly revise. I'll quickly tell you what are these types of matrix. Row matrix. Row matrix means which looks like a row. Simple. Which looks like just a row. That means if I only one row, 1 2 3 4 5, let's say, so only one row is there, only a row is there, that's why I can call it a row matrix. Only one row is there. So the order will become 1 row into 5 columns. So 1 cross 5. Number of rows should be 1 in a row matrix, and similarly in a column matrix, number of columns should be 1. It should look like a column. 5 rows are there and 1 column is there. Zero or null matrix. Zero or null matrix means all the elements inside my matrix are just 0. That's called a zero or null matrix. All elements are 0. All elements are 0. Now, just one more way of writing this, because you'll see in questions in your NCERT also, we can see some questions are in terms of Aij. Now, Aij means I stands for row, J stands for column. So, For example, when we see over here, right, we saw over here, no, A11, so I is 1, J is 1, A12, I is 1, J is 2, A13, I is 1, J is 3, right? So all the elements are defined as Aij, right? Now here all Aij is equal to 0 for all I and J. For all I and J belonging to this matrix, all the elements are going to be 0. That means we have a null matrix, or we also call it as 0. We also call it as 0 or O. Horizontal matrix which will look horizontal, that means which is breadth-wise more, not row matrix. So row matrix is also a horizontal matrix and column matrix is also a vertical matrix. But horizontal matrix specially means which will look broader, horizontally broader. Simple words, right? So for making it horizontally broader, just think what should be more, columns should be more or rows should be more? Obviously columns should be more. So if I write 1 2 3 4 5 6 7 8 9 10 11 12, this is going to be a horizontal matrix because rows are more than columns. So you tell me, if there is a matrix which is of 3 cross 2, what type of matrix it will be? Row matrix or column matrix? Just think about it. Which type of matrix it will be? Yeah, which type of matrix it is going to be? 3 rows and 2 columns, right? So 1 2 3 4, sorry, 2 columns, 1 2 3 4 5 6. This is how this matrix will be, 3 rows and 2 columns. How is it looking? Vertical to you, height wise it is looking longer, or breadth wise it is looking longer? It is looking longer for height. So this is going to be vertical matrix, right? So basically for Aij, in Aij, in all the elements, I should be smaller than J. That means number of rows should be less than number of columns, right? Rows less than columns. If rows are less than columns, definitely we are going to have a horizontal matrix, something like this. Okay, so if my rows are 2 and columns are 3, 1 2 3 4 5 6, rows are 2, columns are 3, 2 cross 3. If number of rows is less than number of columns, I'll always have a horizontal matrix. And similarly, if my number of rows are greater than number of columns, that means, for example, if I have a 5 cross 3, number of rows are greater than number of columns. So 1 2, I can add the elements like this. 5 rows should be there. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15. This will be a vertical matrix. Can you see? 5 is more than 3. Number of rows is more than number of columns, so it is going to be a vertical matrix. Square matrix means rows equal to column. If I have rows equal to column, that means I'm going to get a square matrix. 2 cross 2, 3 cross 3, 4 cross 4, 5 cross 5. Sir, I would score like 30-40 marks, but out of 70 in my school exams, what should I do? Oh, sorry, out of 70, beta, which one? To score 80 out of 100, that I can score at least. Huh. Good question, Sivasakti. So, Sivasakti, I would say, beta, increase your score in maths. Do 3 things, okay? If you do these 3 things, no, even now you have time. Today is what? 4th. 4, 5, 6 and 7. You have 4 days. Okay? You have 6 units and 4 days. Okay? 6 units and 4 days. Listen carefully. First day, complete relation, function, inverse trigonometry. How will you complete? All NCERT questions. First thing, all NCERT questions, all which are there in syllabus. 1.1 and 1.2 are there in your syllabus. Okay, all NCERT questions, all NCERT exemplar questions, and sample paper. 2 sample papers. Only relation functions. Some sample papers where only relation function questions are there. Second thing, second day what you can do? Second day you do matrices, determinants, and linear programming. Okay, 3 chapters. Third day, what you do? Third day you do vectors, 3D, and probability. Vectors is a bit longer, but 3D is small chapter. Probability is also easy and small chapter. Cover NCERT examples, cover all the examples, all the questions of NCERT, and your an exemplar book along with sample paper questions. Okay. And last day you can do calculus. Calculus has 5 units, so you have to make your last day, fourth day, you'll have to make it a big stretch. There you'll have to do a lot. And if you have some time, also solve some sample papers completely within time. You still can score 100% marks. That means 80 out of 80. In maths, it's not that delayed. Okay. Try doing that. Give full 100%. Completely give your 100%. Try your best. Yeah. And then we'll see whatever happens. What is India doing today in cricket match? They're trying their best. Then they'll see what happens. Okay. Just try your best. All right. Square matrix, rows equal to column, 3 cross 3, 4 cross 4, 5 cross 5, 6 cross 6, 7 cross 7. And for studies, Shiv Shakti, you can refer these lectures. So one by one, we are completing everything, right? For revising, you can study over here. In square matrix, AII are called diagonal elements. AII are called, diagonal elements will only be in square matrix. AII means A11, A22, A33, A44, A55 till ANN. Suppose that A11 will be first row, first column. A22 will be second row, second column. A33 will be third row, third column. So this is 3 cross 3. So these are diagonal elements. A11, A22, A33. These are called diagonal elements. Aij and Aji are called conjugate elements. Aij, that means this is your A12. Now A21, that means second row, first column. This one, A21, we have to remember these small terms because questions are asked from these small terms. What is the conjugate element of A12? So A12, A21, right? Similarly, this is A13. So A31, third row, first column. That means this element, A31. Similarly, what is this? This position is, this is left, no? This is A2, second row, third column. So A23. A32, third row, second column. This will be A32. So A12 will be conjugate of A21, vice versa. They are conjugate of each other, right? So 2 is conjugate of 1. Or you can also learn like this, either sides of your diagonal. This one, and these two. Conjugate elements, very important. All right. One more thing which is defined, although it is not defined in NCERT and there are no questions on this, sum of diagonal elements. Just remember this as definition. Sum of diagonal elements in square matrix, matrix is called trace of matrix. Sum of all the diagonal elements. For example, trace of this particular diagonal will be, this particular matrix will be, trace will be equal to 1 plus 5 plus 2. That means 8. Sum of diagonal elements is called as the trace of a matrix. Sure, bro. If you get tired, learn to rest, not to quit. The most way to succeed. Yes, wow. Slide it is giving you, Slide it is given the real motivation. Good, Slide it. You know, we should support each other. Very good. Nice coach, man. I think you're always good at it, right? You write. I remember seeing these type of quotes from your name earlier also. Good. Motivational speaker, huh? There is a good future in that. Okay. Don't underestimate yourself. All right. Square matrix, triangular matrix, diagonal matrix. This is not in our syllabus. Diagonal matrix is a matrix in which only diagonal elements are there. Right? Diagonal matrix means a matrix in which only diagonal. This we don't need to study. Triangular matrix. This is not there in our syllabus. In square matrix, one special type of matrix is there, which is the diagonal matrix. That means only diagonal elements are there. A11, A22, A33, or if it's 3 cross 3, then like this, otherwise more. And these remaining are all 0. Then this will be called as a diagonal matrix. Only diagonal elements are present, rest nothing is present, rest everything else is 0. So you can see, leave this part. In diagonal matrix, only diagonal element should be non-zero, rest everything should be 0. Aij is equal to 0 for all a not equal to j. How to write it mathematically, or somewhere in the question you might see something like this: Aij is equal to 0 for all I not equal to j. That means wherever I and j are not equal, those elements are 0. If they are equal, these are non-zero elements. Scalar matrix. Scalar matrix means if all the diagonal elements are same. All the diagonal elements are same. Suppose if I make a matrix where let's say 2 cross 2. Let's make 2 cross 2 only, no? So let's say 2 2 over here, 0 0 over here. This is my scalar matrix. If I'm making 4 cross 4 and I'm writing 4 4 4 4 over here, this is a 4 cross 4, but this is a scalar matrix. 4 cross 4 scalar matrix because diagonal elements are same and they are non-zero. Diagonal matrix in which diagonal elements are same, that particular matrix is called a scalar matrix. Remember the definitions, they are important. In particular, scalar matrix having 1 at diagonal 1 is called identity matrix, and specific or special type of diagonal matrix which is known as identity matrix or I is of any order, but all the diagonal elements will be equal to 0, will be equal to 1. In identity matrix is a square diagonal matrix in which diagonal elements are all equal to 1. So let's say if we are making 4 cross 4, so it will be like this. Alright, 4 cross 4. So this becomes your 4 cross 4 identity matrix of order 4 cross 4. If I want to make it for 3 cross 3, it will have all 3 ones in the diagonal, remaining everything 0. This is a identity matrix which is a special type of scalar matrix of order 3 cross 3. So do more work for 11th to 12th moving students for JEE. Okay beta, I'll do we are going to continue the PYQ series definitely, Kanan. This is just a bit of halt because right now everybody is busy in boards. That's why we didn't come up with many of the sessions. I also told you that I'll be taking ellipse PYQs in the upcoming week, but I didn't take because I wanted everybody to regain that phase after 8th of March. Right now I wanted to help the students with boards also. Right, one person only, how much? So that's why. But after it, you'll regularly continuously be seeing the content for 11th to 12th moving students and 2026 aspirants completely without any fail. All right, now this one is an important question, has appeared in sample papers, and one similar type appeared 2-3 years back when the pattern was different, but yeah, this can come. This is a very obvious question. Construct a 2 cross 2 matrix where A is equal to matrix of Aij. We have to construct a 2 cross 2 matrix whose elements are given by Aij. I'm doing the first part. I'm only doing the first part. Remaining 2 you can do very easily. Aij is equal to I plus j whole square divided by 2. Every element will be defined like this: I plus j whole square divided by 2. Now 2 cross 2 matrix, so that means there are going to be 4 elements. A11 will be there, A12 will be there, A13 will be there, A14 will be there. Correct? So what will be A11? We can simply calculate A11 from here. I is 1, j is 1. So 1 plus 1 whole square divided by 2, that means 4 divided by 2. So it will be 2. A11 will be 2. Similarly, A12. If I talk about A12 be 1 plus 2 whole square divided by 2, that means 9 by 2. Right? So this will become 9 by 2, or we can write 4.5. Similarly, A2, I marked wrong. Very, my bad. This will be second row, first column, second row, second column. My bad. A21 will come equal to 4.5 only, right? Because I plus j whole square, and A22 will be 2 plus 2. A22 will be 2 plus 2 whole square divided by 2, that means 16 by 2, that will give us 8. So this will be the required matrix, and similarly you can solve the others also. Right? Aij is equal to I by j. So 1 1. So let's say second one also, if we solve Aij is equal to I over j, right? 2 cross 2 matrix. So A11 will be 1 by 1, 1. A12 will be 1 by 2, that means 0.5. A21 will be 2 by 1, that means 2. A22 will be 2 by 2, that means 1. So this will be my required matrix. Very easy questions. In 1 mark they can ask it. In MCQ they can ask it. One question from the sample paper and previous years also similar type. A is equal to 3, 5, 4, 2 and 2A plus B is a null matrix, then B is equal to what? Achha, right now I didn't teach you multiplication actually. So multiplication also is very easy. 2A means 2 multiplied with entire matrix. Although we are going to learn it afterwards, but in this question it is coming, so it's okay. 2 multiplied with entire matrix. So this 2 will go inside and will get multiplied with all the elements. Simple thing, very simple. 2 will go inside and get multiplied with all the elements. So 2 into 3, that means 6. 2 into 4, that means 8. 2 into 5, that means 10. 2 into 2, that means 4 will be getting. So this is our required matrix, which is 2A. Now 2A plus B is a null matrix. One more information I can give you, matrices add up very easily. You can add the matrices very easily. Just add the corresponding elements. For example, I want to add 2A with B. So my 2A is this. I want to find 2A plus B. Right? Here we are doing will be 6, 8, 10, 4 added with another matrix which is B. What is B now? Which is the B matrix? B we don't know. We don't know B, right? We don't know B. So let's say here we'll randomly put elements A, B, C, D, right? They can get added. If actually we should come at this question after learning the properties. Okay, we'll come back at this question. Let's see some other questions. A matrix has 36 elements. The number of possible orders it can have is. This question came last year. Number of how many types of orders it can have. So 36 if we observe, right? 36 if we observe, 2 into 18, right? Then 2 nines, then 3 threes, then 3 ones. How many possible orders can you make? By 1 into 36 will be a possible order, and 36 into 1 will also be a possible order. 1 row 36 columns or 36 rows 1 column. Both will have the order of, both will have 36 elements. M into n always gives you number of elements. M into n, where m is number of rows and n gives you, n is the number of columns. Right, will give you number of elements in matrix. Number of elements in a matrix. Right, how do you get the number of elements in a matrix? M cross n, m multiplied with n. 3 cross 3, that means 9 elements. 3 cross 2, that means 6 elements. Sir, do move. Okay. Now, how else can you get 36? Think of the ways. 2 multiplied with 9 fours. 18 multiplied with 2 can give us, right? Similarly, 2 multiplied with 18 can also give us, right? Now, what else can we do? 4 multiplied with 9, 9 multiplied with 4, 4 multiplied with 9, both will have 36 elements. Then 12 multiplied with 3 and 3 multiplied with 12. Anything else? Anything else which is remaining? One is remaining. (18) and 2, right? This we didn't do, no? Oh, sorry. 2 and 18, 18 and 2 we have done. What else can we do? Just think. One more is there. Come on, write in the chat box if you are here. Come on. Very good. 6 into 6. Very good. 36 is also 6 into 6. 3 into 2 and 3 into 2. Very good. And 6 into 6 is just 1. Right? 1. We'll have to count it as 1 only because we cannot reverse the order. That will be same. That will give us the same matrix. So totally 9 matrix. There is no other way in which we can get 36. There is no other way in which we can get 36 elements. Check and tell me if there is. Come on. Right? These are the all the possible scenarios that we can have. So there were 9. There is no other way. You can check on your own. Take your time. Okay. No other way. Very good. All right. Let's go ahead. Now we'll do algebra of matrices, which is very simple. Very simple. Equality means two matrices will be equal when their corresponding elements are equal. A, B, C, D. Achha, two matrices of same order. They must have same order. Two matrices or matrix can only be equal if they are of same order. Suppose I have A, B, a matrix of 2 cross 1 and another matrix which is C, D, again of 2 cross 1. If they are equal, then A will be equal to C, B will be equal to D. Right? Suppose if my A, B, C, D, E, F is equal to G, H, I, J, K, L. Then simply A will be equal to G, B will be equal to H, C will be equal to I, D will be equal to J, E will be equal to K, and F will be equal to I. One thing, okay? Equality of matrix. So for example, this is a sample paper question and a previous year question also, very simple. So these two matrices are given equal to you, and you are supposed to find A, B, C, D. So A minus B is equal to -1. One equation. Similarly, 2A minus B will be equal to 0. From here we can easily find A and B. Correct? We'll just subtract them. So A minus 2A will be equal to -1. That means minus A will be equal to -1. A equals to 1. If A is equal to 1, B will be equal to 2. B will be equal to 2. Then only 1 minus 2 will become -1. No? Correct? And from the other part where we get 2A plus C will be equal to 5. This element corresponds to this, this element corresponds to this, and 3C plus D, 3C plus D is equal to 13. So A ka value already we have A's value. So A is 1, that means 2 plus C will be equal to 5, and this gives us C equal to 3, correct? 5 minus 2, 3, and this C will put over here. So 3 into 3, that means 9 plus D will be equal to 13. From here we'll get D is equal to 13 minus 9, which is equal to 4. So A is 1, B is 2, C is 3, and D is equal to 4. Simply you have to just equate and make the equations. Easy questions can come from this part. Now adding is also easy. Just add the corresponding elements. 2 will be added to 5, 3 will be added to 1, -4 will be added to 4. Sorry, -4 will be added to 5, 5 will be added to 0, 0 will be, you can see 2 plus 5, 7, 3 plus 1, 4, -4 plus 5, 1, 5 plus 0, 5, 0 plus 2, 2, 1 plus 1, 2. Add the corresponding elements. Very easy thing. Right? Very easy thing. Multiplication is also very simple. Multiplying a constant inside the matrix. This one thing is different in matrices and determinants. Okay, this one thing. Otherwise, addition of determinants also can be done the same way. But this one thing is different. Okay, how? If you are multiplying the entire matrix with a constant term. Let's say if you are multiplying with 2, then 2 will be multiplied to every element. I did that in the question also. If you remember that, right? 2 will be multiplied in every element. Multiplication of true matrix. Now comes multiplication of two matrix. But before this, let's see the question that we left behind. So this question that we left behind was this one. We were doing this, right? Correct. So what did we do? 2A, that means 2 multiplied in the matrix. So 2 will be multiplied to every element. 2 into 3, 6, 2 into 4, 8, 2 into 5, 10, 2 into 2, 4. So 2A is this matrix. 2A plus B is a null matrix. Null matrix, if it is equal, then obviously of same order. Null matrix means all elements 0. Obviously of same order it will be, otherwise we cannot equate only. So 2 cross 2, null matrix. B we don't know. What is B? That we don't know. So we assumed B is equal to B is a matrix which elements are A, B, C and D, right? So it's saying that this plus this is equal to 0. That means 6 plus A is equal to 0. So this gives us A equals -6. Similarly, B will come out to be equal to -8, C will come out to be equal to -10, and D will come out to be equal to -4. So which will be our matrix? -5, -8, -10, -4. C will be our correct option. As simple as that. Okay, now let's move to multiplication of matrix. Multiplication, guys, is very important. Okay, multiplication is very important because many times if you multiply the matrices wrong, no, the long answers which are going to be of 5 marks might come wrong in the calculation. So multiply very carefully. Simple thing, suppose if there is this matrix which is M or let's say P cross Q, you can multiply this matrix to only those matrices in which number of rows, number of columns of first matrix, right? Here commutative law does not hold. AB is not equal to BA, first of all, right? Number of, listen carefully, number of columns in this matrix should be equal to number of rows in this matrix. Okay, you can only multiply. This is called pre-multiplier. This matrix will be called post-multiplier, right? This matrix is called pre-multiplier and this matrix is called post-multiplier. Post-multiplier means which is multiplied next. First term is this, second term is this, for example, right? This over here, my dear friends, this and this should be equal. Then only you can multiply. Otherwise, you won't be even able to multiply. Very good. This is Saditya Vatsa. Okay, all right, very good. Okay, now only you can multiply, and when you'll multiply, the matrix that you are going to have, its order will be P cross R. P cross R. Okay, this matrix order will be P cross R. This is how you can multiply. Only the one condition which you require to multiply is number of columns in this one should be equal to number of rows in the next one. Then only you can multiply, right? A M cross N multiplied with B N cross P. Now we are able to multiply because N and N are equal. Number of columns here, number of rows here are equal. So this is your pre-multiplier, this is your post-multiplier. This will give you a matrix C which will have the order M cross P. M cross P. The C matrix will have the order of M cross P. Remember that. Let's do some examples. Some notes are written. Two matrices can be multiplied only if number of columns of pre-multiplier is equal to number of rows of post-multiplier. Matrices are multiplied in row by column weight of determinant multiplications. Same way determinants are also multiplied, but here we are doing matrices first. So don't worry. Let's see some questions. For example, this one, can we multiply this? Yes, pre-multiplier, post-multiplier, number of columns and number of rows are equal. What we'll get, the matrix that we are going to get. Okay, first, if it's not clear to you, I'll write both the matrix. So this has 2, 3, 4, 1, 2, 3 multiplied with 1, 0, 1, 2, 2, 1, 1, 2, 0, 1, minus 1, 3. Can we multiply them? This is of order 2 cross 3 and this is of order 3 cross 4. Yes, we can multiply them because over here 3 and 3 are same, and result which we are going to get will be of what order? What will be the order of our result? 2 cross 4. So 2 rows will be there and 4 columns will be there. 4 columns, that means 1, 2, 3, 4. 2 rows and 4 columns. Okay, now what do we need to do? How to multiply? This is your A11, right? This is your first row, first column. This element is A11, that means first row, first column. That element, first row, first column element. Okay, first row, first column. So take the first row from this and multiply it with the first column, right? Take 2, 3, 4 and multiply it with first column, that is 1, 2, 0. How to multiply? Multiplication and addition. 2 into 1 plus 3 into 2 plus 4 into 0. So 2 plus 6 plus 0, that means 8 will come here. Okay. Similarly, if you want to know about this one is first row, second column. So 1, 2, first row, second column. So 2 multiplied with 0 plus 3 multiplied with 1 plus 4 multiplied with 1. Okay, 2 multiplied with 0, I'll keep writing also over here. 2 multiplied with 0, this is your A12, right? A1, first row, second column. 2 multiplied with 0 plus 3 multiplied with 1 plus 4 multiplied with 1. So that will give you 3 plus 4, that means 7. Okay, that will give you 3 plus 4, that means 7. Now A13, suppose we are finding A13 first row third column, 2 into 1 plus 3 into 1 plus 4 into minus 1. 2 into 1 plus 3 into 1 plus 4 into minus 1. That means 2 plus 3, 5. 5 minus 4, that means 1. So here what we are going to have, here we are going to have a 1. Okay, now A14 is also there, na? A14 is also there, first row fourth column, that means first row and fourth column. So 2 multiplied with 2 plus 3 multiplied with 2 plus 4 multiplied with 3, 12 plus 6, 18 plus 4, 22 will come over here. 22. Just keep checking, okay? Keep checking this also. Okay, now second row first column, so that means A21, second row first column. So we'll have 1 multiplied with 1 plus 2 multiplied with 2 plus 3 multiplied with 0. That means 4 plus 1, 5 will come over here. Similarly, can we get A22? Second row, second column. Second row, second column. That means this row and this column. So this will give us 1 multiplied with 0 plus 2 multiplied with 1 plus 3 multiplied with 1. That means 3 plus 2, 5 here also. Okay, and similarly we can find A23 and A24. A23 will become 1 multiplied with 1, second row third column. So 1 plus 2 multiplied with 1, 2 plus 3 multiplied with minus 1, that means minus 3. So 3 minus 3, that means here we are going to get a 0. And A24, second row fourth column, that means 1 multiplied with 2, 2 plus 2 multiplied with 2, 4 plus 3 multiplied with 3, 9. 9 to 11, 4, 15. So we'll get a 15 over here, and this will be the multiplication product of these two matrices. This is how you're supposed to multiply 5, 5, 0, 13. 13, 15. Sir, I'm now going to solve NCERT 4th chapters that you told. Can I revisit the session later? Yeah, Siv Sakti. Okay, do that. Please do. Okay, please do. Please do. All right. So 2 cross 4. Okay, now try this also. Can we multiply? Yes, pre-multiplier, post-multiplier, number of columns and number of rows are same. What we will receive? This is 1 cross 1 multiplied with 1 cross 2. So what we'll receive? The order will be 1, this one and this 2. So 1 cross 2. That means 1 row and 2 columns, right? So only 2 elements are going to be there. First element will be A11, second element will be A12. What will be the order? This is 1 cross 2, 1 row and 2 columns. Only 2 elements are going to be present over here. So what will be A11? A11 will be first row, first column. That means 1 into 1 plus 0 into 2 plus 2 into 3, 6 plus 3 into 4. That means 12. 12 plus 6, 18 plus 1, 19. And similarly A12, that means first row, second column. 1, 2, that means first row and second column. So 1 multiplied with 1 plus 0 into 2, that is 0, plus 2 into 0, that is 0, plus 3 into 1, that is 3. So 3 plus 1, 4. 19 and 4, only 2 elements will be there in the multiplication product of these two matrices. Now solve the third one on your own. Okay, what will be the order? This is 1, this is 1. Can we multiply? Yes, we can multiply. And guess what? We are going to get a 3 cross 3 matrix. This is 3 cross 1, this is 1 cross 3. So 3 cross 3, starting one, last one. 3 cross 3 will be our answer. Sir, how, sir? Only one column is there, this thing is there, one row is there. Then how can we get a 3 cross 3? We will, right? And some word problems will be solved by column and vertical matrix, a column matrix and a row matrix. This is one column matrix, this is one row matrix. So how will we get this? A11 will be first row and first column. That means 1 multiplied with first row of this and first column of this. 1 into 1, 1. A12 will be first row, second column. That means 1 into 2. A13 will be first row, third column. First row, third column. That means 1 into 4, 4. A21, second row, first column. Second row, first column. 1 into 1, 1. A22, second row, second column. 1 into 2, 2. A23, second row, third column. 1 into 4, 4. Then these elements. A31, third row, first column, 0. Third row, second column 0, third row, third column 0. This will be our product, and that will be a 3 cross 3 matrix. You can check, right? You multiply 1, 2, 3 with 1, 2, 3. You will get a 3 cross 3 matrix. This is your 1 row and 3 columns. 1 cross 3. This is 3 rows and 1 column. 3 cross 1. Okay? If you multiply like this, see here they multiplied column with row matrix. Now we are multiplying row matrix with column. So is the product same? Let's check. What will be the order of this product? Just think, what will be the order of this product? Sir, the order of this product should be 1 cross 1, because here 3 and 3 are same, remaining 1, 1. So 1 cross 1. That means only one element should come. Only one element should come. What will be that element? A1, 1. That means first row, first column. First row multiplied and added with first column. 1 into 1, 1. 2 into 2, 4. 3 into 3, 9. 9 plus 4, 13 plus 1, 14. So this will be the answer, which is 1 cross 1. This is 1 row, 1 column. Correct? So you see, when we multiplied, let's say this is your matrix A and this is your matrix B. A multiplied with B is not coming equal to B multiplied with A, because here this is B and this is A. Is not equal to B multiplied with A. AB will not be equal to BA in case of matrices multiplication. Remember that. Okay, and sometimes they can ask you to prove or show that for these two matrices your AB should not come equal to BA. Okay, AB should not come equal to BA. This is a PYQ. Let's solve this. Which of the following is not defined? Let's see. BA is defined. Can we define BA? Acha, what is the order of A? Order of A is 3 cross 3. Let me use another color. Order of A is 3 cross 3. Order of B is 3 rows, 2 columns. So 3 cross 2. Can we multiply AB? Yes, because this 3 and this 3 are same. We'll receive a matrix of order 3 cross 2. What is the order of C? 1 row and 3 columns. So 1 cross 3. Can we multiply C with B? No. We cannot multiply B and C, because look, here there is 2 and here there is 1. Number of columns 2, number of rows 1. We cannot multiply B and C. So B into C will not be defined. Can we multiply C and B? Can we multiply C and B? Can we multiply C and B? What is the order of C? C's order is 1 cross 3 and B's order is 3 cross 2. Yes, we can multiply. Look, 3 and 3 are same. It will be a matrix, let's say D, whose order will be 1 cross 2. So this is also okay. BA, can we multiply B and A? Can we multiply B and A? What is the order of B? B's order is 3 cross 2 and A's order is 3 cross 3. This 2 is not equal to this 3. We cannot multiply BA, so this cannot be defined. AB can be defined. Yes, A into B is possible because this 3 and this 3 are same. Number of columns here, number of rows here are same. So this also can be defined. CA, this is C is 1 cross 3 and A is your 3 cross 3. Yes, they can be multiplied because this 3 and this 3 are same. So that's why we'll receive, let's say, a matrix called E whose order will be 1 cross 3. This one and this last 3. Okay, so these type of questions can be defined. Only CA can also be defined. Only BA cannot be defined. This is not defined. Why is this not defined? Because B has order 3 cross 2, A has order 3 cross 3. Number of columns in B is not equal to number of rows in A. So this is not defined. This is not defined. Okay, are we clear? Shall we move ahead? I hope multiplication should be very, very clear, guys. Okay, come on, try solving this question. This was in CB. This is also last year only. This is equal to this. So in simple terms, if this is equal to this, what can I say? X plus Y should be equal to 6. 2 is equal to 2. 5 is equal to 5. This 2 is equal to 2. This 5 is equal to this 5. And XY is equal to 8. XY is equal to 8. Then what do we need to do? This is actually a question of quadratic equations plus matrices. right? We need to find this 24 by x plus 24 by y. I have taken 24 common, so this will become 24 multiplied with x plus y divided by xy. Correct? This y will go here, x will go here, y plus x or x plus y, same thing. We know what is x plus y. We know x plus y is 6. We know xy is 8. So 8 3s are 24 and 6 3s are 18. So our correct answer over here would simply come as 18. How simple was this question? Right? Free ka marks, free ka 1 mark. Okay, objective type. These type of questions can be asked from you. Some more things in algebra of matrices are there. For example, AB will not be equal to BA generally. Generally, it will not be the case. Right? In one case where I can say they'll be equal, just try multiplying this. And try multiplying this. In this case, they'll be equal. Why? Because this is an identity matrix. What we'll get over here, this will be obtained as 1, 2, 3, 4. And this will also be obtained as 1, 2, 3, 4. You can try multiplying if you want to. I'm sure that this will be the answer. Right? Identity matrix. I multiplied with any matrix A will be equal to A multiplied with I. They should be of same order. Okay? Same order. They should be of same order. Okay? In this case, it will be correct. Why? Because when we multiply any matrix with the identity matrix, we get the same matrix, right? Both will be equal to A only. Both will be equal to A. Both will be equal to A. What is A? This is A. And this is your I. So I into A is equal to A into I. Only in this case it will happen. Otherwise, this is not going to be the case. And that is why we can, if we have to somewhere apply, suppose there are two matrices, matrix A is a matrix and B is a matrix. These A and B are matrix, right? And somebody asks us to find A plus B whole square. Then we cannot apply the identity A square plus B square plus 2AB, because 2AB means AB plus BA are added together and made 2AB. Here, in case of matrices, we'll write it like this: AB plus BA, because these both will be different. Yeah, you might have to apply the identities also for matrices. Don't forget that. Okay, let's move ahead. Associative. A multiplied with B, then multiplied with C, or A multiplied with B and C. So, if there are three matrices, associative law will be applicable over there. Commutative law will not be applicable. Matrices are not commutative, but they are associative, right? If you have three matrices A, B and C, you can multiply them in any order you want, right? You can multiply three. Associative means on three matrices this will be applicable, that you can multiply three matrices in any order, but two matrices you cannot change the order and suppose the result to be same. Square matrix only. Correct. Generally, we'll be talking about square matrix only, right? Distributive over addition also. Over addition also they'll be distributive. Suppose two matrices are added, B plus C, then A will be multiplied with B and plus A will be multiplied with C. Here also, if now see post and pre multiplier, here we cannot change the positions. AB will not be equal to BA. So here A is multiplied with B, so you have to write in this order only. A multiplied with C, you have to write in this order only. B multiplied with A, write in same order. Don't write B into A as AB. B into A only, plus C into A. Just remember that, right? For two matrices, changing of order is not allowed. Okay, multiplicative identity exists. I told you I multiplied with any matrix will be equal to the same matrix, and that will be equal to matrix multiplied with I. So AI is equal to IA, and these both will be equal to A. Saying that I and A both are of same order, and same order, just same order. I can be of n cross n. If this is of m cross m, if the A is of m cross n, then you need I to be of m cross m. I generally is a scalar matrix. What is I? Identity matrix is a scalar matrix. Scalar matrix means square matrix, because diagonal elements are all same. Scalar matrix, I is a scalar matrix. Scalar matrix are always square, right? They are always square. So I is always going to be square matrix. Suppose A has order 3 cross 2, then I should be, this I should be of 2 cross 2, right? Suppose your A has order 3 cross 2, then this I should be of 2 cross 2. Okay, and here A has order 3 cross 2, then this I should be of 3 cross 3, right? Because A's order is 3 cross 2, then only you will be able to multiply, na? Right? Here also you will get A, which is of 3 cross 2. Here also you will get A, which will be of 3 cross 2. You can check. Both will give you A, which is of order 3 cross 2. Are you getting my point? This is important to understand. Okay. AI, if you are multiplying, here your identity matrix will be of 2 cross 2. Here your identity matrix will be of 3 cross 3 because I is multiplied with A. So here number of rows and number of columns in this I and number of rows in this A should be equal. Here number of columns in A and number of rows in I should be same. Okay, very important point. Now let's move ahead. Properties. Any matrix multiplied with null matrix give a null matrix. So if you multiply any matrix with 0 of same order or square matrix, null matrix, okay, then it will give you a null matrix only. You will get a 0. That means null matrix. 0 over here, O means null matrix. 0 in some books and some books they use the font as O. Now try doing this question. Come on, try this and post the answer. I'll take a small break, very small break. I'll just check the score and come. Okay, come on. Oh my God. I feel so sad. We have lost 2 wickets. Rohit Sharma went. Rohit Sharma is out right now. Oh, it's okay. It's okay. We'll still win. I still have the hope that India would win. India, India. All right. So A square. First, calculating A square. A square in matrices just simply means A multiplied with A. And a matrix can be multiplied with itself. What is A? This matrix is A. That means 3, 1, 7, 5 multiplied with same 3, 1, 7, 5. This is 2 cross 2. This is 2 cross 2. So the matrix that we are going to get will be also of 2 cross 2. First element A11, that means first row, first column, 3 into 3 plus 1 into 7, 9 plus 7, that means 16. Then 1, 2, first row, second column, 3 into 1 plus 1 into 5, that means 8. Then 2, 1, second row, first column. So 7 into 3, 21 plus 5 into 7, 35. 35 plus 21, 56 we are going to get over here. And first row, now 2, 2, second row, second column, 7 into 1 plus 5 into 5, that means 7 plus 25, 32. Now can we take something common from all of these? Right? Can we take something common? We can take 8 common from all the elements. This will become 2, this will become 1, this will become 7, this will become 4. Correct? We can do that. A square can be written like this, just for the information. So this is your A square. A square is this particular matrix plus xi is equal to ya. X into I. If we are adding something in this matrix, which is A square, this or this, let's take this only. If we are adding in 16, 8, 56 and 32, if we are adding something in this matrix, that thing should be of order, same order should be there. X into I means a identity matrix. Now what should be the, X is a constant, X and Y are the constants, right? So I should be of 2 cross 2 only, right? X multiplied with 2 cross 2 identity matrix, which will look like this, identity matrix, only diagonal elements are 1. X is multiplied inside, so instead of this I can also write x 0, 0, x is equal to y into A. Y multiplied with A. So y multiplied, what is A? A is the main one. So this is 3, 1, 7 and 5. I can also write it as 3y, y, 7y and 5y. Right? All elements will be multiplied. 3y, y, 7y and 5y. Correct? Now this addition should give me this. Okay, 16 plus x should be equal to 3y. That means my 16 plus x should be equal to 3 times of y. And 8 plus 0 should be equal to y. 8 plus 0 should be equal to y. From here I get y equals to 8. And if y is equal to 8, then I'll put it over here and I'll get 24. So my x will come out to be as 24 minus 16. Wow, that means 8 only, right? So x will come out to be equal to 8. So my x is 8 and y is also equal to 8. Option C is my correct answer, and this question is from NCERT. This question is in PYQs also. 23 paper this question was there, and in sample papers also frequently this question is seen. Simple calculation, this is how you are supposed to do. Calculate A square, add x into y, x into same. If you want to add, then order should be same. So x will be multiplied with identity matrix of 2 cross 2. That is this, x multiplied with every element, x into 1, x into 0, 0, x into 0, 0, x into 1, x. Then y into A. A is your main matrix this. So y will be multiplied in every element. And simply you don't need to even check all of them. And you can see y is 8. So 7 into 8 is 56. Correct? 7 into 8 is 56. 5 into 8. That means 40 is equal to 32 plus 8. Correct? It's all clear and correct. Where is the remote? Yeah. Alright. Shall we move ahead? Any voice issue? Please keep telling me the score if you are there. I'm so curious about it. Can I also get the answer? Yes, but you can get the answer. You can get the answer. Square matrix only. Very good. Very good. See, I also get the answer. Okay, very good. Very good. Very good. That's good. Okay, keep solving with me, and these 2 chapters will be covered for you. You don't have to do too much more practice for this. This question again from sample papers and from books. Good question. These type of questions you should be able to solve. Simple manipulation. You just have to show, verify that a plus b minus c, that means associative property of addition you have to verify. Sometimes for multiplication, but multiplication will come in 5 marks. These type of questions can come in 2 and 3 marks. We'll also see 5 marks questions. Okay, so a plus b minus c. First we'll do b minus c. So 3 minus, so a is, your a is what? 1, 2, simply write a as it is, 1 minus 1, 1, and b minus c, so 3 minus 4, minus 1, minus 1 minus 1, minus 2, 2 minus 2, 0, 4 minus 0, 4, 2 minus 3, minus 1, 5 minus 2, 3, 2 minus 1, 1, 0 minus minus 2, that means 2, and 3 minus 3, 0. This is your first left side. This is your LHS. Right, what are we getting in LHS? What matrix are we getting? 1 minus 1, 0. 1 plus minus 1, that means 0. 2 minus 2, 0. Minus 3 plus 0, minus 3. 5 plus 4, 9. 0 minus 1, minus 1. 0 plus minus 1, minus 1. 2 plus 3, 5. 1 plus 1, 2. Minus 1 plus 2, that means plus 1. 1 plus 0, 1. Right, this is your LHS. Now RHS. Solve RHS. What is a plus b? Check a plus b. What will be a plus b? A plus b you find first. 1 plus 3, 4. 2 minus 1, 1. Minus 3 plus 2, minus 1. 5 plus 4, 9. 0 plus 2, 2. 5 plus 2, 7. 1 plus 2, 3. Minus 1 plus 0, minus 1. 1 plus 3, 4. Added with, subtracted from c. Subtracted from c, and c you can write as it is 4, 1, 2. 0, 3, 2, and 1 minus 2, 3. Right? Can we check? Both results are same. 4 minus 4, 0. 1 minus 1, 0. Minus 1 minus 2, minus 3. 9 minus 0, 9. 2 minus 3, minus 1. 7 minus 2, 5. 3 minus 1, 2. Minus 1 minus minus 2, that means minus 1 plus 2, which will be 1, and 4 minus 3 will be equal to 1, and you can see LHS is equal to RHS, hence proved. So simple questions are going to be asked in boards. You can cover this chapter and master this chapter very easily. Pay attention and practice this and get done over it. Simplify this, simplification of this. This is also a 2020, no, this is NCERT question, but this type of questions have been asked. Cos theta is multiplied inside the matrix. So when cos theta is multiplied, cos theta will be multiplied with every element. Cos theta into cos theta, cos square theta. Cos theta into sin theta, cos theta, sin theta, or sin theta, cos theta, no problem. Sin theta, cos theta. Cos theta into minus sin theta, minus sin theta, cos theta. Cos theta into cos theta, cos square theta. Plus sin theta into sin theta, sin square theta. Sin theta into minus cos theta, minus sin theta, cos theta. Sin theta, cos theta, sin theta, cos theta. And sin theta into sin theta, that is sin square theta. When we add them, what do we get? Cos square theta plus sin square theta 1, sin theta cos theta minus sin theta cos theta 0, minus sin theta cos theta plus sin theta cos theta 0, cos square theta plus sin square theta 1. That means we get I of 2 cross 2. You can write like this also, I, that means identity matrix of order 2 cross 2. Okay, you can easily simplify these type of questions. Let's see this comparison, simple comparison. 3 is multiplied inside, so this matrix will become 3x, 3y, 3z and 3w. Okay, which is equal to addition of these two. So x plus 4, 6 plus x plus y, minus 1 plus z plus w, and 2w plus 3. 2 times w plus 3. These are equal. So one by one we can compare. 3x is equal to x plus 4. From here what do we get? X equals 2. Correct? 3x equal to x plus 4. So x will be equal to 2. x will be equal to 2. Now 3y, this is first, now second, 3y is equal to 6 plus x plus y, where x is 2. So 6 plus 2 plus y, so 8 plus y, right? So from here what do we get? Y is equal to 4, right? 3y minus y, 2y is equal to 8, y is equal to 4, right? So from now third one, 3z is equal to this, and we will use this one first. 3w is equal to 2w plus 3. So from here w also we are getting, w will become equal to 3. We got w also. And fourth one is 3z equal to minus 1 plus z plus w, and w is equal to 3. So this will give us 2z is equal to 2. 2z is equal to 2. That means z is equal to 1. So we found all the values x, y, w and z. Simple questions are going to be asked. These are 2 or 3 marks. These can be asked in 2 or 3 marks. This particular question, this type of particular, this is NCERT question and also in sample papers, right? This type of particular question can be made. I expect that they can give something like this. Adding function of x defined as a matrix. So show that f of x, your f function of x is defined as a matrix, and the matrix is this: cos x minus sin x 0, sin x cos x 0, 0, 0, 1. This is your f of x. So f of y will become, what will f of y be? F of y will be nothing but cos y minus sin y 0, sin y cos y 0, 0, 0, 1. This will be f of y. Now you just have to show that f of x multiplied with f of y will be equal to f of x plus y. This you have to prove. And for this, one more thing, you'll have to find what will be f of x plus y. What will be f of x plus y? Just put, instead of x, put x plus y. So it will be equal to cos of x plus y minus sine of x plus y 0, sine of x plus y cos of x plus y 0, 0, 0 and 1. This will be it. So multiplication of these two you have to do, and that you have to show equal to this, which can be easily proven, right? F of x, that means this matrix, cos x minus sin x 0, sin x cos x 0, 0, 0, 1, multiplied with f of y, that is cos y minus sin y 0, sin y cos y 0, 0, 0, 1. Sin of a plus b, sin a, cos b plus cos a, sin b. Correct? Skip these type of questions because it's verification like questions. Bit of verification also they can ask you in 3 marks. They can ask you, especially this particular type, you should be able to prove. Right? Simply here, I know you can prove it. Cos x cos y plus sin x sin y. So cos of x plus y. See, cos x into cos y minus sin x into sin y. So that is cos of x plus y plus 0. Right? So first element definitely is going to come cos of x plus y. Here just trigonometric formulas application. Now second element, first row, second element. First row, second column, cos x into minus sin y. Right? Cos x minus sin y multiplied with minus sin x cos y. Right? Minus of sin x plus y. It will become negative of sin x plus y. You have, while proving, also write the formulas. Also write all the 4 formulas: sin of a plus b, cos of a plus b, sin of a minus b and cos of a minus b. Write all of them. Right? If you are doing this directly. So this will come out to be 0 because first row, third column. This into 0, 0, this into 0, 0, 0 into 1 is also 0. So this will be 0. Similarly, here we'll get sin of x plus y, cos of x plus y. Here we'll get a 0, here we'll get a 0, 0 and 1. And you will multiply. These are simply application of sin a plus b, sin a minus b, cos a plus b and cos a minus b. Sin a plus b is sin a cos b plus cos a sin b. Sin a minus b is sin a cos b minus cos a sin b. Cos a plus b is cos a cos b minus sin a sin b, and cos a minus b is cos a cos b plus sin a sin b. Those 4 formulas you will have to be writing while verifying these or showing these. Now, word problem can also be seen in the board exams. Using matrices, how will you solve the word problem? This is a problem from I think your book only. The bookshop of a particular school has 10 dozen chemistry books. 10 dozen chemistry books, that means 10 into 12. That means 120. Okay, 8 dozen physics books. Physics books are 8 dozen, so 8 multiplied with 12. So 96. Okay. And then 10 dozen economics books. Economics books are 10 dozen, so 10 multiplied with 12, again 120. Their selling price are 80, 60 and 40 each. Find the total amount of bookshop. Find the total amount the bookshop will receive from selling the books using matrix algebra. Using matrix, you have to showcase this particular type of problem. Come on, think, how can you do that? Just think for a minute. How can you do that? Easily. How can you do that? But you want, how will you calculate the selling price? There are 120 chemistry books, 96 physics books and 120 economics books. To each selling price are 80, 60 and 40 each. This is 80, this is 60, this is 40, right? Rupees, let's say rupees. Now total selling price you have to calculate. How just mathematically think, how will you calculate? 120 into 80 plus 96 into 60 plus 120 into 40. That's what you are going to do. So simply just make this as a row, 120, 96 and 120. Okay, and make a column over here, because what do you need? You need 1 row 3 columns, right? So this is 1 row 3 columns, and now here will be 3 rows 1 columns, right? So 3 rows 1 columns, that means this is going to just make 80 over here. 120 you want to multiply with 80, plus 96 you want to multiply with 60, and plus 120 you want to multiply with 40. So these two metrics when multiplied will give you the answer. This will be the problem. This will be the matrix algebra method of showcasing this word problem, right? So this is 1 cross 3, 1 row and 3 columns, and this is 3 cross 1. So finally you'll receive a matrix which will be of 1 cross 1, right? 1 cross 1, and this element you can obtain simply by 120 into 80 plus 96 into 60 plus 120 multiplied with 40. That will be your answer. Check total answer. 20160 will come over here. 20160 will be the total price. This is just a 1 cross 1 matrix. This is how you'll have to showcase your word problem with matrix algebra. Similar type of problems can come. So method is just naturally, how will you solve it? Just think that and try to represent it as a matrix problem, and always your answer should be 1 cross 1. Always your answer should be 1 cross 1. So you have to make a row matrix and a column matrix. Which should be a row matrix, which should be a column matrix. Here I can also do this can also be represented like this: 80, 60, 40 multiplied with 120, 96 and 120. This can also be showcased like this, no problem. But row into column, it will be row into column. Column into row, if you'll do, no, column into row, if you'll do, you'll have 3 cross 3 matrix, which is not the solution. This will also give you 20160. Okay, remember this method. Now transpose. Transpose means interchanging the rows and columns. Simple thing. Suppose I have a matrix which is A, B, C, D, E, F, G, H, I, J, K, L, M, N and O. Okay, what is this? 5 columns and 3 rows. So 3 cross 5. Okay, if I want, let's say this is my matrix A. A transpose can be written with A dash or A and above that a T. So T, A dash or A transpose, where I'll just interchange rows and columns. All the rows will become columns and all the columns will become rows. So you can do anything. Start with this row. Make this as the column. make this as the column. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O. So if the order of A is 3 cross 5, order of A transpose will be 5 cross 3, 5 rows and 3 columns. Okay, 5 rows and 3 columns. Just interchange the rows and columns. That is called a transposed matrix or A transpose. Transpose of a matrix. Make all the rows as columns. That's it. Okay, very easy thing. Let's move ahead. Some properties, although these are not there in your syllabus, problems based on these are also not there, but sometimes they can ask something in MCQ. I'll show you. Sometimes they have asked questions from properties of matrices and determinants in MCQs. So just telling you for the information so that if anything comes like that. A transpose over transpose. Suppose this is A transpose. If I find transpose of A transpose, that means I again interchange the rows and columns. So what will this become? This row will become column. That means A, F, K. This row will become column. That means B, G, L. This row will become column. That means C, H, M. This row will become column. That means D, I, N. This row will become column. That means E, J, O. Again, I got the same matrix which was A. So transpose of a transpose matrix will be the same matrix obtained. A plus B transpose. Transpose of A plus B is also equal to A transpose plus B transpose. Right? If K is multiplied in transpose, you can take that K out. K is a constant. K can directly come out of transpose. This is important, and sometimes they can ask you to verify this. So try verifying this on your own. A and B are two matrices. Multiply them and find their transpose, and find the transpose of B multiplied with transpose of A. So reversal law will work here. AB whole transpose will be equal to B transpose multiplied with A transpose, not A transpose multiplied with B transpose. Reversal law. This is also called reversal law of transpose. This they also call as reversal law of transpose, and they can ask you to verify this. So how to verify? Multiply AB, find their transpose, and then find B transpose separately, A transpose separately, multiply both of them in this order only. B transpose into A transpose is not equal to A transpose into B transpose. Commutative property does not apply in the multiplication of matrices. Remember that. Okay. In case of three matrices also it will work like this. Reversal law, C transpose, B transpose, A transpose, it will become. Okay. If A square transpose, if we are finding transpose of A square, or we are finding square of A transpose, both are going to be the same thing. Similarly, it applies for cube, power 4, power 5, power n. Right? Power can go inside and outside of transpose. Transpose of A square or square of A transpose, both will give us the same matrix. Both will be equal to one another. These are some properties of your transpose. Now, some special types of matrix based on transpose are defined in our syllabus, which are two matrices, symmetric and skew-symmetric. These are obviously going to be square matrices. Symmetric matrix. Symmetric matrix means that in a square matrix of order n is called symmetric matrix if all Aij is equal to Aji. That means A12 is equal to A21. A13 is equal to A31. A23 is equal to A32. Okay, let's say for 3 cross 3 matrix we are talking about. Now this is your A11, this is your A11, this is A22, this is A33. So for these are diagonal elements. On these we'll not talk about transpose. Now let's check which is A12. This is first row second column 1 2. And is this equal to A21? Yes, this is equal to A21. This is your A13 first row third column. Is this equal to A31 which is third row first column? Yes. A31 and A12 are equal. A23 second row third column. This is your A23. Is this equal to A32 third row second column? Yes, this is equal to A32 third row second column. This is exactly equal. right? So yes, this is a symmetric matrix. This is a symmetric matrix. Whenever Aij is equal to Aji for all ij, that means that is a symmetric matrix. Now tell me, 1 2 2 2, is this a symmetric matrix? A12 is equal to A21. That means symmetric matrix. That means all the in simple words, all the conjugate elements across the diagonal, right? Not conjugate also, all the conjugate elements only we'll call it. A21 is a conjugate of A12. So all the conjugate elements across the diagonals, if they are equal, then it is called a symmetric matrix. Okay, then it is called a symmetric matrix. Okay, one more thing here we can see. Now if I okay, 2 1 3, let me take this matrix separately. So let's say this is a symmetric matrix. Okay, 2 1 3 1 0 minus 2 and 3 minus 2 5, 3 minus 2 and 5. This is your A. This is, let's say, your A. What will be A transpose? A transpose will be again 2 1 3 1 0 minus 2 3 minus 2 5. This will be A transpose. Rows and columns interchanged. All rows are made 2 1 3 1 0 minus 2 and 3 minus 2 5. Okay, now for symmetric matrix, always A multiplied with A transpose will be equal to A. A multiplied with its transpose, if this is giving you equal to A, that means you have a symmetric matrix, and you can check also, right? 2 1 3 1 0 minus 2 and 3 minus 2 5 multiplied with A transpose, which is again 2 1 3 1 0 minus 2 and 3 minus 2 5. This is going to give you again an A. 3 cross 3 multiplied with 3 cross 3 will give you. So you can check. Multiply the first row with first column. Just check for a few elements. 2 into 2 4, 1 into 1 1, 3 into 3 9. Okay, check over here. Oh, I'm sorry. No. I've written wrong actually. No. I made a mistake over here. No. It won't come equal. Actually, it won't come equal. Right? It won't come equal. In symmetric matrix, the product is not. That's orthogonal. In symmetric matrix, if your A transpose is equal to A, that means you have a symmetric matrix. Sorry, my bad. I take my words back. A into A transpose is equal to A for orthogonal. Is equal to I for orthogonal. We get those type of things. Here we'll not get. That's a different property. If it's a symmetric matrix, then A transpose will be equal to A, and you can see A trans. That's what I was thinking. Why are they equal? A transpose is coming out to be equal to A, and it will only happen in the case of symmetric matrix where Aij will be equal to Aji for all I and j. So if A transpose is equal to A, that means you have a symmetric matrix. Okay, you can see A transpose is equal to A. It was written also over here. Second is skew-symmetric matrix. Another is skew-symmetric matrix. That means Aij and Aji are equal but are of opposite signs. Aij is equal to minus Aji. Here you can see A12 is equal to minus of A21. A13 is equal to minus of A31 and A23 is equal to minus of A31. They are of opposite signs. In this case, this is a skew-symmetric matrix, and when you'll find the transpose of it, right? If you'll find the transpose of it, let's say this is A, and if you find A transpose, this will be equal to 0 2 4 minus 2 0 minus 3 and minus 4 3 0. So these two are not equal, you can see, right? But if you take minus common from these, so if you take minus common from all the terms, this will become 2, this will become 4, minus common, so this will become minus 2, this will be 0, minus 3, this will be 4, this will be 3, and this will be 0. Yes, but minus of this is equal to this. So in this case, you'll get A transpose is equal to negative of the matrix. A transpose is equal to negative of A. If you are getting this case, then you will have a skew-symmetric matrix. Now, very good questions can be made based on symmetric and skew-symmetric matrix. For that, first try to learn these, right? These two. That always half of A plus A transpose will be a symmetric matrix. A matrix added to its transpose and divided by 2 will always be a symmetric matrix, and A minus A transpose will be a skew-symmetric matrix. You have to prove that. Just think, how will you prove that? And A is a square matrix, right? A is a square matrix. Come on. I'll just take a small break. Very simple. How will you prove that? This is in your NCERT examples also. How will you prove that? Let's say this is X or any matrix B. Let's say X is equal to half of A plus A transpose. Okay. Actually, you don't need to have half also, but all right. Now take transpose on both the sides. Take transpose. You can take transpose on both the sides. No problem in that. Take transpose on both sides. So X transpose will be equal to half of, or entire thing, half A plus A transpose. Taking transpose on both the sides. Right? See, they won't keep properties of matrices in syllabus, but properties of transpose in syllabus, but they can give you these type of questions. These type of questions have come and they are in your NCERT also. Okay, so X transpose left side, this side half will come out of the transpose, right? It will be A plus A transpose whole transpose. Now transpose gets distributed over addition, we saw in the properties. So X transpose will become equal to half of A transpose plus A transpose. Correct? Transpose of transpose will again become A. So your X transpose will be equal to half of A transpose as it is plus A. So in addition, matrices are commutative, so this can also be written as half of A plus A transpose. Now what we'll say, because X transpose is equal to X, you see X transpose again came out to be equal to X only, hence X is a symmetric matrix. This is how you'll have to prove it. This is how you are going to prove it. Okay. Similarly, half of A minus A transpose. So let's say X is equal to half of A minus A transpose. Actually, we don't need half. Just for making the question different, we have added half over here. Why people didn't come here? But people didn't come because it's India is batting right now. India is batting right now, maybe that's why. Now taking transpose on both the sides, so X transpose will be equal to half of, I'm already taking half outside, A minus A transpose whole transpose. Okay, so X transpose will become equal to half of A transpose minus A transpose transpose. Correct. So X transpose will be equal to half of A transpose minus A. So X transpose can be written equal to minus, taken out common, A minus A transpose. Right. So we can say that X transpose is equal to minus of X. This was X. And X transpose is equal to minus of X. Hence, X is skew-symmetric. Hence, X is skew-symmetric matrix. Hence, we can say that X is a skew-symmetric matrix. Are we clear? This is how we can prove these two things. All right. Acha, okay. This we did, right? Already, both. All right. Sample paper questions or previous year. This is, I think, previous year question. No, sample paper maybe. All right. So A is given and we have to verify A dash into A is equal to I. Actually, this is for a special type of matrix which we call as orthogonal, but that's not there in your syllabus. Here we just need to verify A dash into A is equal to I. Yes, so simply for first one, let's say if I'm proving, so cos alpha, sin alpha, minus sin alpha and cos alpha multiplied with transpose of, first we have to take transpose. Order matters in matrices. So A transpose will be what? A transpose will become cos alpha sin alpha over here and minus sin alpha into cos, minus sin alpha and cos alpha over here. This row became this column, this row became this column. Okay, multiplied with A will take again, which is cos alpha sin alpha and minus sin alpha into, and sorry, I am saying into again, right? Cos alpha. Now when we'll multiply, we are going to get a 2 cross 2 matrix only. 1 1 1 2 2 1 2 2. 1 1 means first row first column, cos into cos, cos square, minus sign into minus sign, plus sign. So cos square plus sin square, that means 1. Okay, first, now 1, this is 1 2, first row second column. So first row into second column, cos into sin minus sin into cos, 0. Correct. Now 2 1, second row first column, sin into cos minus cos into sin, 0 over here. Then second row second column, 2 2, sin into sin, sin square plus cos into cos, cos square. So again 1, which is an identity matrix of order 2. Same will happen for second one also. These type of questions can come very easy. Let's see this. A is given to you, A plus A transpose is given equal to 1. Then the value of alpha will be what? Solving a trigonometric equation, not a problem. A plus A transpose, that means cos alpha minus sin alpha, cos alpha plus transpose. That means transpose of this, so cos alpha minus sin alpha will come here and sin alpha and cos alpha will come here, is equal to I, right? Is equal to I, that means 1. Cannot be equal to 1. Matrix does not have a value. Determinants have a value. Okay. Sir, please post recorded videos because the strength is less in people. Yes beta, don't worry. I won't, I don't get upset. I know that the crowd on this channel is very less right now, but I know that some students are getting benefited. Don't worry, I don't get upset, I don't get disheartened. Don't, I've taught on bigger channel also, but not a problem, bro. You know, I'm actually, I've always wanted to help the students who face difficulty in understanding the lectures in Hindi. And second thing is, I also believe that we should study in English, not in any regional language. It's don't think with my don't think that I'm an anti-nationalist or anything by this statement. This statement just means, because further also the career paths which we have chosen, suppose we are meeting somewhere, you know, national language is Hindi, state languages are there, other languages are also comfortable, but which language connects the entire world? Think about it. Which language will connect the entire world? You go to Australia, you go to Thailand, there people will be speaking Thai, but they'll understand English. You go to Singapore, people will be, Sri Lanka, people will be speaking Sinhalese, but they'll also understand. Everybody will understand English. So English is something in which we should do our studies. I love my national language. I love many languages, in fact. Tamil I like. I know a little bit of Telugu also. Hindi is my mother tongue, and I love all of these languages, but I still believe that we should study in English. Why am I saying that? Because you know the comfort of being able to converse in English won't come otherwise, and this is important. Trust me, it's important to be confident in speaking English. Not writing literature and all that is okay, but you have to be confident in speaking English, and that will only come when you listen English, when you speak English. That will only come like that. And you know, I faced a lot of problem. I belong from a small town called Kota, if you have heard the name. Definitely, if you're anybody preparing for IT would have heard the name Kota. I belong from a very small town, Kota. My English teacher used to translate my entire book into Hindi, and that's how we used to study English. I could not speak English at all. I went to my college. My college was in Chennai. Okay, Anna University, if you have heard of, right? So there I felt so bad, because all the South Indian students, all the metro city students were speaking very well in English, and I could not even talk to them. For 3 semesters, I didn't talk to people. I talked to only those who were able to speak, or who were from my state or from my city. Otherwise, I was not talking to anybody, because I was very underconfident in English. I was like, I didn't knew, my English was completely broken. And I faced a lot because of that. In many interviews I faced a lot because of that. And then I thought that yes, the only way I can improve my speaking in English is by teaching in English. So when I came into teaching, I always tried, maximum times I try that if I can teach in English, that's okay. I've taught in Gulf, I've taught US students, and that gives me confidence in speaking English, and that also proves that yeah, this is important for us. This is actually, studying in English is very important for us. Sir, in front of my eyes you are like, oh my god, Legend Gaming, what are you saying? Come on, you're going to make me fly. All right, a plus this is equal to 1. So this is equal to I means an identity matrix of order 2 cross 2. So cos x plus cos x, that means 2 cos x is equal to 1. Minus sin x plus sin x is equal to 0. Sin x minus sin x is equal to 0. And here also 2 cos x equal to 1. So cos x is equal to 1 by 2. And if you look in the principal branch, then what is the value? 60, pi by 3. So x is equal to pi by 3. Very simple. Okay. So these type of questions can be asked. Now, very important thing, and on the basis of this, there is one question in your NCERT also, and it can be asked in boards also. What is this thing? That any matrix can be represented as a symmetric and a skew-symmetric matrix. What did we just now learn? We just now learned that half of A plus A transpose is a symmetric matrix, and half of A minus A transpose is a skew-symmetric matrix. So a matrix A can be represented as a sum of symmetric and skew-symmetric matrices formed by A only, right? And you see, this question I was talking about, this is in sample papers, right? This is in sample paper of 2025. So 5-mark question can be made out of this particular concept. What are they saying? They are saying that express B as sum of symmetric and skew-symmetric matrix. So how will we start? We'll say that, we'll say we know, okay, first thing, given and all you can write, so I'm starting after that. We'll say that we know that half of B plus B transpose is a symmetric matrix. Right, this is how. So whenever you are, if you are getting this question, get this matrix and this matrix, these two. So get this. That means half of B plus B transpose will be equal to half multiplied with okay, first we'll find B plus B transpose. No, first we'll find B plus B transpose. So B plus B transpose, that means this matrix, which is 2 minus 2 minus 4 minus 1 3 and 4, okay, and 1 minus 2 and minus 3. Okay, then find B transpose. Plus B transpose will be what? 2 minus 2 minus 4 will come here. Minus 1 3 4 will come here. Minus 1 3 4 will come here. 1 minus 2 minus 3. 1 minus 2 minus 3. Okay ji. B plus B transpose, what will this become? So B plus B transpose, let's say B plus B transpose will come out to be 2 plus 2 4, minus 2 plus minus 2 minus 1 minus 3, minus 4 plus 1 minus 3, 1 plus minus 2 minus 1 minus 2 minus 3, 3 plus 3 6, 4 minus 2 2, 1 minus 4 minus 3 minus 2 plus 4, that means 2, and minus 3 plus minus 3, that means minus 6. This will be your B plus B transpose. Okay, then you can do half, right? So half of B plus B transpose will be equal to, just multiply half inside. Okay, so this will become 2, this will become minus 1.5, minus 1.5, what was this here? Minus 1 minus 2 minus 3, na? Minus 1.5. Okay, I'll stretch this a little bit. Okay, minus 1.5, 3, 1, minus 1.5, 1, and minus 3. Okay, this will be your half of B plus B transpose. Similarly, do for A. Similarly, do half of, and here write. So here you can write, we know that half of B minus B transpose will be a skew-symmetric matrix. Write like this. Okay, half of B minus B transpose will be a skew-symmetric matrix. Okay, so we'll find B minus B transpose now. B minus B transpose. Luckily, we'll have B and B transpose from here. So B minus B transpose, that means 2 minus 2 will be 0. Minus 2 minus minus 1 minus 2 plus 1, that means minus 1. Minus 4 minus 1, that means minus 5. Minus 1 minus minus 2, that means minus 1 plus 2, that means 1. That's correct, right? 3 minus 3, that means 0. 4 minus minus 2, that means 4 plus 2, that means 6. 1 minus minus 4, so 1 plus 4, 5. Minus 2 minus 4, that means minus 6. And minus 3 minus minus 3, that means minus 3 plus 3, that means 0. Okay, and then we'll write half of B minus B transpose. So this will become half multiplied inside, half into 0, 0, half into minus 1, minus 1.5. Minus 1 into half is minus half, so minus 1.5. Minus 5 into half, that means minus 2.5. 1 into half, that means minus 1.5. 0 into half, 0. 6 into half, 3. 5 into half, 2.5. 6 into half, minus 3. And 0 into half, 0. Okay. Now, take these two matrices. Okay, I'll have to write. So, now find half of B plus B transpose plus, or this entire thing. You can take common from both of them, or you can do like this also. Okay, like do simple way. Half of B plus B transpose minus, plus half of B minus B transpose. Find this. Okay, this is symmetric, this is skew-symmetric. We have already proven that. Okay, we have already proven that, and here also you can directly write. You don't need to prove this part separately. So half of B plus B transpose is 2 minus 1.5 minus 1.5, or we should have taken half common only here. Why did we do this much of Jamila? All right, but no problem. So we'll write 2 minus 1.5 minus 1.5 minus 1.5 3 and 1 minus 1.5 3 and 1 minus 1.5 1 and minus 3 minus 1.5 1 and minus 3. Okay, this is your first part, and second part will be from here. 0 minus 1.5 minus 2.5, 0 minus 1.5 minus 2.5, and minus 1.5 0 minus 1.5 0 and 3, then 2.5 minus 3 and 0, 2.5 minus 3 and 0. See, it's a 5-mark question. 10 marks, 10 minutes you'll have to spend in these type of questions. Now add these two. Add these two. 2 plus 0, 2. Minus 1.5 minus 1.5, 3. Minus 1.5 minus 2.5, 4. Minus 4. Right? Right? So, and minus 1.5 minus 1.5 again minus 3. 3 plus 0, 3. 1 plus 3, 4. Minus 1.5 plus 2.5. How much? 1. Right? Positive 1. 1 plus minus 3. 1 minus 3, that means minus 2. And minus 3 plus 0, that means minus 3. Look at this. This is exactly B or not. 2 minus 2 minus 4, minus 1, 3, 4, 1 minus 2 minus 3. 2. Something wrong we did. Kya? Minus 3, minus 1. Oi. Something wrong. Did we take the matrix correctly? Yes. So I think some calculation mistake we have done. This should come exactly as B. Symmetric and skew-symmetric. A minus A transpose we did correctly. Just check the calculation once. Minus 3, first of all, this should be. Okay. But it's minus 2. Minus 1 multiplied with half is 0.5. Yaar. Sorry. Here it will be 0.5. 5 half is 2.5. 1 half is 0.5. This is 0.5. 0, 6, 3. Okay. 5, 2.5. Minus 3, 0. Okay. Now, so 0.5 we'll have to replace at two places over here. 0.5 and this will be minus 0.5. Now it will come correct. So this will become your minus 2, correct? Correct? No, no. And this will become minus 1.5 plus 0.5, that means minus 1. Oof. Correct? 3, 4, 1 minus 2, 3 is correct. Now it's correct. This is B. Right? This is your B. So you have represented B is equal to half of B plus B transpose plus half of B minus B transpose. That means B is equal to symmetric plus skew symmetric. Hence proved. Okay. Alright. So this can be done. Now inverse of matrix, although in matrix chapter they are not talking much about inverse of matrix, but in determinants, in the determinant chapter, you will need the use of inverse of matrix, because according to syllabus in determinants they have mentioned this thing. In determinants they have mentioned inverse of a matrix and adjoint of a matrix, but in matrix chapter they have not mentioned adjoint and inverse. So we'll be studying this. I'll just take a small break. Okay, I'll be back in a minute. Kohli is playing, guys. Kohli is playing. My man, my man. It's so good. All right. Okay. So inverse. Right now in matrix we'll do a very small introduction of it. What is written? We'll see. Inverse means AB will be BAB multiplied with BA, both if they are equal to identity matrix, then in that case we'll say B is inverse of A, and vice versa, that A is inverse of B. B is inverse of A and A is also inverse of B. And formula for A inverse that we'll introduce later, it is given as adjoint of A divided by determinant of A. This part will introduce later. I'll come to it, don't worry. And one property here you should remember, in inverse also reversal law holds. AB inverse, this much part only is there in your matrix chapter. AB whole inverse is equal to B inverse multiplied with A inverse. Reversal law also holds for transpose as well as matrix. Okay, now A inverse exists if A is non-singular. Non-singular, singular means if your determinant of the matrix is equal to 0, that means singular, otherwise non-singular. We'll again come to this part. For now, only this much is required for you. Only one example, one question is there in the matrix chapter. I'll tell you that question also if I can find. That question is this: matrix A and B will be inverse of each other only if. So there are 4 options, right? Only one question is there in NCERT. Inverse of matrix will exist. Matrix will exist only if, and there are 4 options. Only if there are 4 options in this. I'll read the options also for you. Options are AB is equal to BA. Option B is AB is equal to BA is equal to 0, that means null matrix. Option C is AB is equal to 0 and BA is equal to identity matrix. Option D is AB is equal to BA is equal to I. Only if, so your correct answer will be AB should be equal to BA, both should be equal to an identity matrix. In this case, we'll say that A inverse is equal to B and B inverse is equal to A. Okay, in this case we can say that in matrix chapter only this much part is there. Now we'll come to introduction of determinants, right? Some more part of matrix is there in the determinants chapter. Determinants means value of matrix, and determinants are only defined for square matrix. Determinants are only defined for square matrix. In a determinant, number of rows and number of columns are always equal. That means determinant will be only for a square matrix, right? You can write also somewhere, determinant is only for a square matrix. Okay, now what will be determinant? Determinant, instead of these type of brackets, we have straight line brackets, right? 2 straight lines. If we enclose elements in 2 straight lines, this will be called as a determinant, and very easy to solve that. Here also Aij means, I means row, J means column. Easily we can solve that. Order A11, order 1, 2 cross 2, that means order 2, 3 cross 3, that means order 3, and we won't have anything above 3 cross 3. 4 cross 4 determinant, if they can ask you to solve, that's not a problem, but otherwise maximum it will be of 3 cross 3 only. Now how to solve? Order first. Okay, order of A cross A matrix. What will be the value? So 1 cross 1 matrix, so determinant A is -3, order 1 cross 1, so its value will be -3. For order 2, how to solve this? A11 into A22 minus A22 into A11. Simply cross multiply and subtract from left to right. A11 into A22 minus A21 into A12. This will be the value of the matrix of order 2. Just remember it like that. Simply remember it as it is. Okay, this into this minus this into this. Simply, right? Order 2. Now we'll come at order 3 and other things. Relation between matrices and determinants is, we find determinant only of square matrix. That I already told you. We can only find determinant of a square matrix. If A and B are 2 square matrices of same order, then determinant of A multiplied with B will be equal to determinant of A multiplied with determinant of B. So determinant can be broken in multiplication, that you have to remember. This thing also is very important. A square, determinant of A square will be equal to square of determinant of A, and similarly we can say determinant of A cube will be equal to cube of determinant of A. So you find the square of matrix and then find its determinant, or you find the determinant of matrix and then square it. Both will be the same thing. Very important property of determinants. Third thing, if A is a square matrix of order n and K is a constant, then K to the power, now if suppose this is your suppose some A matrix you have of order n, suppose 2 cross 2 matrix you have, and K is multiplied with every element. Now what happens in determinants, the property will come later. I'll show you this property first actually. So yeah, not here, it will be property 3. Nahi. Okay, leave it. It's not, I'm not able to find it right now. So let's go back. I'll explain like this only. Don't worry. Actually, in determinant, no. If you want to take out common, then you can take out common from either any row or any column. Row wise or column wise. For example, suppose if my determinant is 2, 4, 8, 1, 2, 3, 4, 6 and 12. Okay, now I can take 2 common but not from all, and this is determinant, not a matrix, right? If it was a matrix, then I cannot take 2 common because 2 is not there in all, 2 is not common in all the elements. 1 and 3 I cannot take out 2 common. But if it is a determinant, how will I take 2 common? 2 can be common, 2 can be taken out common from row or a column, from entire row or from entire column. So can you take out 2 common from any row? Yes, from this row I can take out 2 common. So this will become 2 multiplied with 1, 2, 4, 1, 2, 3, 4, 6, 12. Now one more row I can take 2 common from this row also 2 will come out common. So again one more 2 I can take out common, right? So this will become 1, 2, 4, 1, 2, 3 and 2, 3, 4. So this will be the final determinant. This I have to solve. So 2 is taken out common from 2 rows. If it could be taken out column from column also, common from column also if entire column had 2 as a multiple. So in determinant, constant is taken out common row wise or column wise. Okay. Now suppose your matrix is 3 cross 3. Suppose your matrix is 3 cross 3 and your elements are like this: KA, KB, KC, KD, KE, KF, KG, KH, KI. Okay. Now this is your matrix. If you are finding determinant of it, now K will come. Now this is actually K multiplied with, this is actually K multiplied with this entire matrix, which is ABC, DEF and GHI. Right? K is taken out common from, K is multiplied inside. But if we are finding the determinant of this matrix, right? If we are finding the determinant of this matrix, that means determinant of KA, KB, KC, KD, KE, KF, KG, KH and KI. Right? If we are finding the determinant of this matrix, then K will come out common from first row, then K will come out common from second row, and K will come out common from third row also. So it will be K multiplied with K multiplied with K, and then this matrix, which is ABC, DEF, G, H, I, this determinant. So K cube into the same matrix, same determinant. So you see, if A is a matrix of order n and K is multiplied in the matrix, and if you are finding the determinant of that matrix, then K to the power n will come out. Because this was 3 cross 3. What is n? N is the order. This is n cross n. An means n cross n matrix. So K will come out from all the n rows. So K to the power n will come out of the determinant. If you are finding the determinant of matrix, which is K multiplied with A, where A is a matrix of order n, then from determinant k to the power n will come out. Very important property this is. Okay. All right. Here also determinant of a to the power n will be equal to determinant of a to the power n. So simply this is saying that you find determinant of a square or you find determinant of a and then square it. Both will give you same result. Power will go inside and outside of determinant also. This thing is important. Okay. So if in matrix k is multiplied with every element and k is taken common out, constant can be taken common out if it is present in all the elements. But in determinant you can take the constant common from rows wise or column wise. So column wise also if you will take, then also 3k's will come. Row wise you take, then also 3k's will come out and will be multiplied. Right. All right. So this is the thing. Now let's move ahead. Here you can see, right? K A. This is a 3 cross 3 matrix. K into A3 will be K, 2k, 3k, 3k. This thing. And when we'll find the determinant of it, K multiplied with A3. Determinant of K multiplied with A3. So K will come out from this row, and this row, and K cube will come out, and this will become determinant of A3 as it is. Determinant. This is determinant of A, which is of order 3 cross 3. So K cube will come out. If the order is n, then K to the power n will come out. If the order is anything 5, then K to the power 5 will come out, right? Okay. This question. Come on, assertion and reason. Come on, tell me, is assertion and reason both correct? Is assertion correct, reason not correct? Assertion is correct, reason is correct, and reason is the correct explanation of assertion. You know the 4 options. To write in the comment box or try to think which one will be correct. Which one of these will be correct? Come on. Try to think, solve, and then give your answer. Actually, we have to learn to solve a 3 cross 3 matrix first. All right. Okay, I'll tell you how to solve a 3 cross 3 matrix first. Right. then only we can come to this question. Then only if you have solved, very good. Otherwise, I'll tell you how to solve this question. So 2 cross 2, you can simply solve a12 multiplied with a22. Sorry, a11 multiplied with a22 minus a12 multiplied with a21. Okay, but for 3 cross 3, how to solve? So there are two things, minor and cofactor. This is your exercise 2 of determinants, I think. This is your exercise 2 of determinants, or 1 or 2. 2 or 3, sorry, 2 or 3 of determinants, where you are asked to find minors and cofactors, but we have not seen questions like that. Now for 3 cross 3, I'll tell you what is minor and what is cofactor. Okay, so minor of 1 1, for example, minor of 1 1, minor of a11 will be minor of 1 1. Minor of 1 1 means the determinant which will be formed after hiding the corresponding row and column of a11. That means hiding the row and column of corresponding row and column of a11. What will be remaining? Only this determinant will remain, a22, a23, a32 and a33. This determinant will remain. So this will be minor of 1 1. Similarly, minor of 2 2. So in this case, now minor of a12, let's say we are finding row wise. So let's say finding minor of 1 2, minor of 1 2. So for 1 2, corresponding row is this, corresponding column is this. Which determinant will remain? What determinant will remain? a21, a23, a31 and a33. This will remain. Similarly, suppose we want to find the minor of a13. So hide corresponding rows. What will remain? This determinant will remain, right? A21, a22, a31 and a32. Correct? The determinant, this determinant's value, all these determinants will have value. These are determinants. Determinants have value, right? Matrices don't have value. Now let's say a21. M21 we are finding, minor of 21 will be the determinant which is formed on hiding the corresponding row and column of 21. So what will be the determinant that will remain? A12, A33, A12, A33. Sorry, A12, A13 and A32 and A33. Okay, this will be the minor. Similarly, M22 if you want to write, so what will you have to hide? These A11, A13, A31, A33, right? A11, A13, A31, A33. All these will have value. These will be the minors. Then comes cofactor. Cofactor of ij will be minus 1 to the power of I plus j multiplied with minor ij. So suppose cofactor of 1 1 we are finding. Suppose we are finding cofactor of 1 1. It will be minus 1 to the power of 1 plus 1 multiplied with this minor 1 1. That means this one, M11 multiplied with M11. This will have a value. Similarly, C12 will be minus 1 to the power 1 plus 3, sorry, 1 plus 2 multiplied with M of 12, minor of 12. Cofactor, in cofactor we'll have to just multiply minus 1 to the power of I plus j. Similarly, A13 for example will be minus 1 to the power 4 multiplied with M of 13. That means minor of 13. C21 will be equal to minus 1 to the power of 3 multiplied with M21. Right? M11, M12, M13 and M21 we have already found. Right? These will have values. This will be A22 into A33 minus A32 into A23. This will be A21 into A33 minus A31 into A23. Right? So this you can find, and for 3 cross 3 only we'll have to do. Now this is minor and cofactor. Alright. But suppose you want to calculate the determinant's value. Suppose you want to calculate the determinant's value and suppose you want to write the determinant which has cofactors, with its cofactors. So this is the way. Okay, this will be the way. This will be the correct way. Just remember this sign. Okay, plus here this is A11, so plus sign, minus 1 to the power 2 will be plus. This is A12, so minus 1 to the power 3 negative. A13 minus 1 to the power 4 positive. This will be A21, so negative. A22 will be positive. A23 will be negative. A31 will be positive, A32 will be negative, A33 will be positive, minus 1 to the power 6. So remember these signs. Okay, this is how in a 3 cross 3 it will appear. Now let's move ahead. Now how do we solve a determinant? So A11 will be multiplied with its A11 will be multiplied with its cofactor determinant, right? A11 will be multiplied with its cofactor determinant, or you can say A11 multiplied with minus 1 to the power 1 plus 1. Just write here, multiply minus 1 to the power 1 plus 1. A12 will be multiplied with minus 1 to the power 1 plus 2, and A13 will be multiplied with minus 1 to the power 1 plus 3. So only this will become negative. 1 plus 2 minus 1 to the power 3 will be negative, and minus 1 to the power 4 will be positive, minus 1 to the power 2 will be also positive. So A11, if you are solving row wise, if you are you can solve column wise also. This you can do with column also. You can do like this also. A11 multiplied with its cofactor determinant, that means similarly A22, A23, A33, A32, A33, right? Plus A21 multiplied with minus 1 to the power 2 plus 1. So that means negative. Instead of plus, negative. I am solving column wise. So A21 multiplied with minus 1 multiplied with its minor matrix, you can say, because cofactor we have already developed by multiplying this minus 1. Cofactor we generally say, according to definition, sum of product of elements of any row with their corresponding cofactors is the value of determinant. But cofactors, for cofactor we just need to multiply with minus 1 to the power I plus j. That we have already done. Okay, so minus will be there. Now minor matrix A21, what will be the minor matrix for A21? Hide this, A12, A12, A13, right, A32 and A33, right, plus minus 1 to the power 1 plus 3, minus 1 to the power 3 plus 1, that means minus 1 to the power 4, which will be positive, so it will be a plus only. So A31, column wise we are solving. So now we'll write the cofactor matrix of A31, which is A12, A13, A22, A23. This also we can do without any trouble. So this is how we'll solve a matrix. These will give you, this will become A23 into A3. What happened here? This will be 3, right? So let's go back to that question which came last year. Let's see how can we solve it. Okay, so first of all let's solve row wise. Let's say we are solving row wise. So first element, that is A11, 1 multiplied with its cofactor matrix, cofactor determinant, that means 1 cos theta minus cos theta and 1 plus minus 1, here minus 1 to the power 1 plus 1 we have done, so positive. So just remember in, or you can remember in 3 cross 3 matrix, second term will be negative, right? So minus 1 to the power, because minus 1 to the power 1 plus 2 will be minus 1 to the power 3, which is negative. So minus cos theta, second element row wise is cos theta, and determinant corresponding, its cofactor determinant will be, so we'll hide this and this. So minus cos theta minus 1 and minus cos theta. Okay, right? And similarly plus 1 multiplied with its cofactor, so minus cos theta, 1 minus 1 and minus cos theta, and we'll solve this simply. So this will become 1 into this, so 1 minus cos square theta. So 1 minus cos square theta will give you 1 plus cos square theta. Remember this minus this, 1 into 1 minus cos square theta. Cos theta into minus cos theta will be minus cos square theta, minus will become plus. Minus cos theta into cos square theta minus cos theta, right? So minus cos theta into cos theta will be cos square theta minus cos theta, that means plus cos theta, right? This minus this for square, plus 1 into cos square theta minus minus 1, that means plus 1. So let's see what are we getting. 1 plus cos square theta minus cos cube theta plus, sorry, minus cos square theta plus cos square theta plus 1. So cos square theta minus cos square theta got cancelled. What are we getting? We are getting minus cos cube theta. This is what we are getting, no? Oh, one mistake we have done. This is 1, right? Cos theta, when we took this and this. That's what I'm thinking. How is cube coming? This is 1 over here. So I think from here we'll have to solve. Sorry, my bad. 1 plus cos theta minus of cos theta into minus cos theta plus cos theta. Minus cos theta plus cos theta it will become. Right? Plus 1 into cos square theta plus 1. Okay, this is what we are getting. So this will become 0. This will become 0 and we'll get 2 plus 2 cos square theta. 2 plus 2 cos square theta. Right? This is the value of A. This is your determinant of A. This is your determinant of A. Matrix A was defined and then they are saying determinant A belongs to 2, 4. The value of determinant of A will be between 2 and 4. When theta is between 0 to 2 pi. And what will be the reason? Reason is that when theta is between 0 to 2 pi, cos theta will be between minus 1 to 1. We know cos theta maximum value is 1, minimum value is minus 1 between the interval of 0 to 2 pi. Right? So if cos theta is between minus 1 to 1, right, from here we can say, given that cos theta is between 1 and minus 1. So cos square theta will be less than 1. Cos square theta will be less than 1. 2 cos square theta will be less than less than 2. Will be less than, we can say 2 cos square theta will be less than 2. Both sides multiplied 2. Plus 2 if we do, right? 2 cos square theta plus 2 if we do. So 2 plus 2 cos square theta will be less than 4. Correct? Will be less than 4. Oh, and this side will have a 0, right? This side will have a 0. So cos square theta will be between 0 to 2, or it will be all positive. When we square, this will be between 0 to 1. 2 cos square theta will be between 0 to 2, and 2 plus 2 cos square theta will be between 2 and 4. And greater than equal to will come always, right? Because cos theta can be equal to 1 and minus 1. So yes, you can see 2 plus 2 cos square theta is between 2 and 4. And the reason is this only. So assertion is correct, reason is correct, and reason is the correct explanation of assertion. This question came in 2024. Actually, this is a bit lengthy for a 1 mark question, but yeah, not lengthy also, right? You have to solve the determinant, that's it. And this is what you have to check, that 2 plus 2 cos square theta, which is the value of determinant of A, is oscillating between 2 and 4. And that's what is written in assertion. And reason is this only. Why is this? Because cos theta is between minus 1 to 1 in the interval of 0 to 2 pi, and here also it is given that theta is between 0 to 2 pi. Please don't forget to like the session if you're there. Okay, and subscribe the channel. Okay, let's move ahead. So, if the elements of row and columns are multiplied with cofactors of any other row and column, then the sum is 0. This is a property. If you multiply the elements of any row with cofactor of any other row, then the required result will become 0, right? But we don't use it anywhere. Now, main thing is, which is exercise 3. Exercise 2, I think, is area of triangle, which you can ignore because area of triangle based questions are hardly asked, but we'll also practice that anyway. Minors and cofactors, right? Exercise 3rd, I think, is of minors and cofactors. So minors and cofactors of A21 and A32. For example, they are asking what will be the minor and cofactor of A21 and A32. So A21 minor of A21 will be nothing but, which is second row first column, that means this element. So we'll hide this, and the minor will be the remaining determinant, which is 0, 3, 1, 9, and its value will be 0 minus 3, that means minus 3. 0 minus 3, that means minus 3. Similarly, if we are for A32, M21 will be what? M21 will be, so M32 will be what? Third row second column, which is third row and second column, this element. So we'll hide this much. So remaining determinant is 1, 3 and 2, 1. What will be the value? 1 minus 6, that means minus 5. Okay. Cofactor of 2, 1 will be minus 1 to the power of 2 plus 1 multiplied with M21. Correct? So minus 1 to the power 2 plus 1, that means minus 1 multiplied with minus 3, that means 3 will be the cofactor of 2, 1. And similarly, C32 will be minus 1 to the power of 3 plus 2 multiplied with M32, which is minus 1 to the power 5, which is minus 1 multiplied with minus 5, that means 5. This is how you can find the minors and cofactors also. Minor and cofactor of all the elements of determinant of A. So simply for 3, now look at the positions. Write the minor and cofactor elements. So A11 we have, A12 we have, A21 we have, A22 we have. Okay. Minors of, let's say Mij we are making, like just writing the minors. So minor of A11 will be this one, hide this and this, so minus 5. Correct? For this one, minor will be this. For 6, minor will be 2. And for minus 5, minor will be 3. These are minors. But cofactor determinant will become, now this is A11, so minus 1 to the power 2, that means positive. Positive into minus 5, that means minus 5. Correct? This is A12, minus 1 to the power 3. So negative. Negative into 6, so negative 6. This is A21, that means negative. So negative 2. And this is A22, that means positive. So simple technique, I'll tell you, to write the minor or cofactor determinant of a 2 cross 2 matrix. Interchange these two. This will become minus 5, this will become 3, and interchange these two with signs. So this will become minus 6 and this will become minus 2. What did I say? So suppose your matrix is 1, 2, 3, 4. Okay, 2 cross 2 matrix, and you want to write the cofactor matrix of this or cofactor determinant of this. So what will you do? Interchange these two as it is. This will become 4, this will become 1, because at these two places sign won't change. At these two places sign will change. So interchange these two with changing the sign. That's it. This will be the cofactor matrix of this particular matrix. That's the small trick. And that is also true for, remember I showed you one thing over here. Yeah, this thing. So here also, minus you will have to multiply this position, this position, this position and this position. Remaining you don't have to multiply with minus. If you are supposed to write the cofactor matrix of a 3 cross 3 matrix, then minus will be multiplied only at these 4 positions: A12, A21, A23 and A32. Okay, that's it. All right, let's go ahead. Value of determinant won't change even if you transpose the determinant, right? A and A transpose, both of their determinant will be equal to one another. Determinant of A and determinant of A transpose will both be equal. It won't affect the value of determinant. Property 1. Property 2 says if any 2 rows of a determinant are, although properties are not there in your syllabus, right, very few are there, very few things are there about them, so that's why. Second property says if any 2 rows or any 2 columns of determinant are interchanged, then the sign of determinant will change, right? For example, suppose your determinant is 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, and you interchange the first row and second row. So this will become 4, 5, 6, 1, 2, 3 and 7, 8, 9. You can solve and check. This will be negative of this. Whatever value comes out of this will be negative of this. Will be negative of this. You can right now itself try by solving if you like. Okay, we have lost 2 more wickets. So it's 81 runs required on 82 balls. My God, this is a tough match. Yeah. For odd number of interchanges. So suppose I interchanged once and I interchanged again. 2 times I interchange. So minus minus will become plus. If 3 times I'm interchanging, minus 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 will remain minus. 4 times I'm interchanging, minus 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 will become plus. So for even number of interchanges, sign will remain same. Right, and for odd number of interchanges, sign will change. Sign will be opposite. That's it. Okay, that's the key over here. This is what property 2 says. In any row of a determinant is jumped. Okay, this is all right, not a problem. If any 2 rows of determinant are identical, then the value of determinant is equal to 0. You can check this. Check for 1, 2, 3, 1, 2, 3 and 3, 2, 1, let's say, or let's say like this. 2 rows are same. Okay, 2 rows are same. And also check for this 1, 2, 1, 2. This will be definitely 0. 2 minus 2 equal to 0 in square. In 2 cross 2, you can clearly see that. Now here 1 multiplied with 4 minus 3 minus 2. I'm solving row wise. Minus 2 multiplied with 2 minus 0 plus 3 multiplied with 1 minus 0. So what will this give us? This will give us 1 minus 4 plus 3. So 1 minus 1 will be equal to 0. Whenever you have 2 rows same or 2 columns same, you can directly say that the value of determinant is going to come equal to 0. This will help you in solving, especially in mains, right? In boards, I don't think they use properties in any of the questions. In NCERT also, they have not used much of properties. If any element of any row be multiplied by number k, then value of determinant is multiplied by k. If obviously, just now we saw, right, this property only we learned, no? That if we have Ka, Kb, Kc, one row multiplied with k, right, one row is multiplied with k. So this will be equal to k times of A, B, C, D, E, F, G, H, I. We already learned this property, right? Multiplication of a constant inside the determinant is either row wise or column wise. Either it will be this or it can also be equal to AK, DK, GK, B, C, E, F, H, I. So we can take K common from column or take K common from row. We can also interchange like this. These things can be done in determinants. Now in the second exercise you have this, right? Area of a triangle whose vertices are x1, y1, x2, y2 and x3, y3 will be determined by this half of x1, x2, x3, y1, y2, y3, 1, 1, 1, this determinant, half of this particular determinant. And you must have learned this formula in your class 10th also. Half of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2, right? How do you remember this? How do you remember this? So if this is x1, y1, x2, y2, x3, y3, let's say. So if you are taking x1, then you will take these two, difference of these two, y2 minus y3. If you are taking x2, after x2 comes y, so plus x2, then y3 minus y1. Plus you are taking x3, the two other remaining are y1 and y2, so y1 minus y2. in the same order. Multiplied this, multiplied with this, multiplied with half, this value multiplied with half, obviously mod of it. If it's coming negative, area cannot come as negative. Now this question can be asked, this is in your NCERT also and in sample papers also, this type of question can be asked. Find the value of k if area of triangle is 4 square units and the vertices are this. So k, 4, k, so directly you should apply the formula. You can write in the determinant k, 4, 0, 0, 0, 2, 1, 1, 1, right? All x, all y and all 1, right? This will be equal to 4. This should be equal to 4 because area of triangle is given to you equal to 4. Okay. All right. So we'll solve this. So k multiplied with 1 minus 2. Sorry, 0 minus 2. This into this 0 minus 2 into 1, 2. So minus 2. Right. Cofactor determinant will be this one, right? Correct. Minus 0 into anything will be 0, 0 into anything will be 0, so we don't need to write this one, plus 1 multiplied with its cofactor, that means 8 minus 0, that means 8. So this will give you minus 2k plus 8, which is equal to 4. That means minus 2k equal to minus 4, so k is equal to 2. Your value of k will be equal to 2 in the first case, right? Second one you can solve, right? Second one you can solve on your own and solve some more questions. Suppose if they want to if they ask you to prove that these three collinear points, suppose they want you to prove that for what value of k will these be will these three be collinear, for what value of k will these 3 points be collinear. So you just have to make determinant equal to 0 because area of collinear points will come out to be 0. Area of triangle formed by collinear points will come out to be 0. So what you need to do, minus 2k plus 8 equal to 0. So you will get k is equal to 4. For k equal to 4, these three are collinear, and for k equal to 2, the area formed by the triangle, the area of triangle formed by these three vertices will be equal to 4 square units. So both the types of questions you should be practiced with. Now, for example, this question came in MCQ, right? 2024, this last year only. So x plus 1 multiplied with this and x minus 1 multiplied with this. What should you do? Simply multiply only will do. X plus 1 multiplied with x square minus x plus 1 minus x minus 1 multiplied with x square plus x plus 1. This you'll have to solve. An answer over here will come out to be equal to 2. When you will solve this, simply just multiply and solve. So this will become x cube minus x square plus x square minus x plus 1 minus x cube plus x square plus x minus x square minus x minus 1. Right. So when we'll open this, x cube cancels x cube, minus x square and minus x square will become 2x square. X and minus x will get cancelled. X and minus x will get cancelled. Minus x square and minus x square. Achha, minus x square only will be there. Kya? Oi. Plus x square na bhai. X cube minus x square. Okay. Minus x square minus x square. Minus x square plus x square 0 na. Minus x square plus x square 0. X square minus x square 0. Right, minus x plus 1 minus of minus x minus 1, so 1 minus 1, 2 only will be coming, so 2 will be your correct answer. That's it. One more property actually I reminded of telling you over here. So x to the power 4 plus x square plus 1, this can be factorized at x square minus x plus 1 into x square plus x plus 1. Just for the information I'm telling, maybe somewhere you might need to use this. Okay, so find the value of this. K is being multiplied. So what you can do, take 5 common from this row. So this will become 5 into 4 minus 3 and 24 and minus 24, let's say, right? This will be equal. Now take, what can you take common? 24 you can take common from this row. So 5 multiplied with 24, determinant will be 4 minus 3, 1 minus 1. And this will become minus 4 minus minus 3. That means minus 4 plus 3, that means minus 1. So minus 1 into 24 into 5. That will be the answer. That's it. This, suppose you have to show. Now this can be, for this you don't need to solve the determinant. This question I've put, this is a matrix and they are asking you to show that 3a is equal to 27a. So now determinant of 3 times a, 3 multiplied inside the matrix, right? And if 3a will be 3 multiplied inside the matrix, and if we are taking determinant, this 3 will come out of the determinant as 3 to the power 3. Why? Because matrix is of 3 cross 3. So 3 to the power 3 will come out and this will remain as it is. So it will be equal to 27 determinant of A, already proven. This is how you have to prove if this type of question come in 2 marks. Okay, you can write K-A-N where is equal to K to the power N, determinant of A, where An is a matrix of order n. An is a matrix of order n. This simply you can write. Alright, let's move ahead. Okay, for any square matrix, now we have come on adjoint, because in determinants adjoint and inverse are mentioned. In the chapter of determinant, adjoint and inverse are mentioned, and sometimes you have seen questions also in your exams. So what is an adjoint? Or how do we find an adjoint? That we are going to learn in this chapter. Sorry, just a minute. I'll just take a minute. Okay, sorry. Right, let's come to adjoint of a matrix. How do we find the adjoint? First of all, we'll have to learn that. And also one more property, adjoint will only exist for a square matrix. First of all, a matrix multiplied with adjoint of that matrix will be equal to determinant of matrix, repeat after me, multiplied with identity matrix of order n, right, will be equal to adjoint of A multiplied with matrix A. So A multiplied with adjoint of A is equal to adjoint of A multiplied with A, and simple terms, simply adjoint, and they are equal to determinant of A into identity matrix of order n. Right? Determinant of A into identity matrix of same order, where A is also of order n. Right? So in simple terms, you can write adjoint of A multiplied with A is equal to determinant of A into I. I will be of order, same order, which is of our matrix A. All right, let's move ahead. Now, point is how to find the adjoint. Okay, how to find the adjoint. For example, do we have some questions over here? No. We'll have. I'll take a matrix. I'll take a few matrices because it's important to learn how to find the adjoint. Okay, it's important for us to know how to find the adjoint. So let's take two matrices. And let's take a 3 cross 3 matrix also. For both of them, we'll learn how to find the adjoint, which is going to be important for the upcoming exams of ours. Okay, let's take 1 minus 2 4 0 2 4, or let me take up minus 4 5 3, so that we don't make a mistake. That's why I'm just taking a already taken matrix. Okay, so let's take it as 1. Okay, now how to find the adjoint of matrix. Adjoint of a matrix is nothing but transpose of the cofactor matrix of A. Remember, we learned just now how to find the cofactor matrix of A. Simply for 2 cross 2, it's very simple. Cofactor matrix of A will be what? We'll interchange these two as it is. This will become 5, this will become 4. We'll interchange these two with changing the sign. So minus 1 will come here and this will become 1. This will be the cofactor matrix of A. And adjoint of A will be transpose of this. That means 5 minus 1 and 1. This will be adjoint of A. Adjoint of A is a matrix, not determinant. Remember that. Okay. Adjoint of A will be this. Now, in case of 3 cross 3, all right, no problem. We know how to find the cofactors. Right. So, first we'll find cofactor matrix of B. Right. Cofactor matrix of B we'll find. So, for 1, what will be the cofactor? For 1. Cofactor will be minus 1 to the power 1 plus 1. So basically minus is going to come here, here, here and here. We know that. Right. Rest all will be positive. Okay. So 1 multiplied with its cofactor matrix, cofactor determinant, that means 6 minus 5. That means 1. So 1 will come here. 1 into 1. Right. Cofactor. For 1 cofactor determinant will be this much. 2, 1, 5, 3. So value will be 6 minus 5. That means 1. For minus 2. What will be this thing? 3 into 0, right? We'll hide this and this. So 3 into 0 minus 4 into 1. So 0 plus 4 multiplied with minus. So here we'll have a minus. Here we'll have a minus. Minus 4. Here positive only. For 4 we are doing. So we'll hide this and this. That means 0 minus 8. That means plus 8, so it will remain plus only. Now here we'll have to multiply with minus. For 0, what will be the remaining? Minus 2, 4, 5 and 3. So minus 6 minus 20. 3 into minus 2 minus 5 into 4. That means minus 6 minus 20. That means minus 26. Minus 26 multiplied with minus will give us a positive 26. Here we'll have a positive 26. For 2, hide this and this. So 1 into 3 minus 16. That means 3 plus 16. So it will be 19. And here we'll also multiply with minus. For 1, what will it be? 1 into, for 1 it will be, 1 into 5 minus 8. 5 minus 8, that means minus 3. Minus 3 with minus, if we'll multiply, it will become positive 3. Very carefully you'll have to do it, right? Do it on your own also, otherwise you might end up making a mistake in the exam. For minus 4, let's say we are doing, for minus 4, what will it be? Minus 2 minus 8. Minus 2 minus 8, that means minus 10. And this will remain, this is what position? A31, minus 1 to the power 4. Minus 1 to the power 3 plus 1. So positive only. So minus will not be multiplied with anything. It will remain minus 10 only. For 5 also we can find 1 minus 0, that means 1 only. 1 minus 0, that means 1 only, but minus will be multiplied over here. This is 3, 2. Right? And for 3, it will be 2 minus 0, that means 2 only. So this. Now, adjoint of B will be transpose of this matrix. That means 1 minus 4, 8, 26, 19, 3 and minus 10, minus 1, 2. Check if I have not made any mistake, just check once. Okay. This is adjoint of B. Okay. Now let's do this question which is there in your sample paper. A is a two row squared matrix where determinant of A is equal to 6. Then A multiplied with adjoint of A will be what? A multiplied with adjoint of A will be what? This is an MCQ. So just now we learned a property that A multiplied with adjoint of A will be determinant of A multiplied with I of same order. So I will be order of, I's order will be 2 cross 2. Correct? Now A multiplied with adjoint of A. Right? This is what they are asking. A multiplied with adjoint of A. We know it is going to be equal to determinant of A, which is 6, multiplied with identity matrix of order 2 cross 2. So this will be nothing but 6 multiplied inside the identity matrix. That means nothing but 6006. That means our answer is option number D. So we have to remember this formula. Don't forget this formula. Okay. Inverse of matrix. We just now saw A multiplied with adjoint of A is equal to determinant of A multiplied with identity matrix. Correct? And we know that A multiplied with B, if it is equal to I and this is equal to B multiplied with A, then A and B are inverse of each other. Now, if I take this determinant on the left side, suppose A multiplied with adjoint of A divided by determinant of A, this will give me I. Correct? Now, product of two things is giving me an identity matrix. A multiplied with B is I and B multiplied with A is I. Then A is the inverse of B and B is the inverse of A. So, adjoint of A divided by determinant of A will be the inverse of A. Correct? So, A inverse, from here what do we learn? From here we learn a simple thing that A inverse will be adjoint of A divided by determinant of A, and this determinant of A should not be equal to 0. That means A should not be a singular matrix. Singular matrix means its determinant is equal to 0. Non-singular matrix means its determinant is not equal to 0. Right? It's written. A inverse exists only if matrix A is invertible, only if it is non-singular. That means its determinant is not equal to 0. Remember that. And what will be the A inverse? A inverse will be nothing but adjoint of A divided by determinant of A. Simple thing. So for example, we have to verify. We have to find B inverse and A inverse. Right? A, B inverse. Now first of all, what we'll do? We'll find adjoint of A. Right? Adjoint of A. For finding adjoint of A, this is your A. Right? 3, 7, 2, 5. Cofactor matrix CFM I am writing of A will be what? Change these two 5 and 3 and interchange these two with signs. Correct? And adjoint of A will be your transpose of this. So interchange rows and column. 5 minus 2 will come here, minus 7, 3 will come here. This is your adjoint of A. Correct. So A inverse will be what? A inverse will be this matrix multiplied with this matrix divided by this matrix divided by sorry, this matrix divided by determinant of A. What will be determinant of A? From here, determinant of A we can simplify in 15 minus 14, that means 1. So A inverse will be nothing but this matrix, 5 minus 7 minus 2 3 multiplied with 1 only, divided by 1 only, so same thing. Okay, similarly your B, what is your B from here? Your B is this 6 8 7 9, and cofactor matrix of B will be 9 minus 7 6 and minus 8. Right, interchange these two and interchange these two by changing the signs also. And so your B adjoint of B, what will be your adjoint of B? Find adjoint of B, or adjoint of B can be written like this also. Adjoint B will be transpose of this, that means 9 minus 7 and minus 8 6. Correct. This will be adjoint of B. So B inverse will be what? B inverse, what will be your determinant? First find determinant also. Determinant of B will be 9 6 are 54 minus 8 7s are 54 minus 56. So minus 2. Minus 2 will be the value. So this divided by minus 2. So 1 upon minus 1 by 2 multiplied with 9 minus 8 minus 7 and 6. Now you have to verify that AB whole inverse is equal to B inverse into A inverse. So first multiply AB and then find its inverse. It's a 5-mark question. So first you'll have to multiply A and B and then find its inverse. So A and B when multiplied, what is our A? 3725. 3725. What is our B? B is 6879. 6879. These are the two matrices. Right? This will be multiplied and this will give us AB. What will be AB? 3 into 6 plus 7 into 7, 49 plus 18, 67. Okay. Similarly, 3 into 8 plus 9 into 7, 63 plus 24, 88. Just check the calculations. Okay. Now this one, first row, this is 2 1. So second row, first column, 2 into 6 plus 7 into 5, 35 plus 12, 47. Correct. Second row, second column, that means 2 into 8, 16 plus 9 into 5, 45. 45 plus 16, 61. Right. This will be your AB. Now AB whole inverse you need to find. For that you'll have to find adjoint of AB. Okay. So first cofactor matrix will be your 61, 67, minus 47 and 88. Okay. Then you'll find adjoint of AB. Adjoint of AB will be equal to 61 minus 47 here, 88 and 67 over here. Correct. Then you will be finding AB inverse. 67 into 61 minus 88 into 47. This we'll have to calculate actually. So because determinant of AB you need to find, no, or you can calculate on your own. Can somebody tell me if anybody is live right now? Minus 49 is coming. Okay, minus 49 will come. This determinant of AB will be minus 49. Determinant of AB will be minus 49. So this will become minus 1 by 49 multiplied with this matrix, which is 61, 88, minus 47 and 67. This will be a 5-mark question and you'll have to do all these manipulations. Now you can do the multiplication of A inverse into B inverse, sorry, B inverse into A inverse. and then compare it with AB inverse. So what will be B inverse into A inverse? B inverse will be 9 by 2 minus 9 by 2, right? Okay, minus 9 by 2 and then positive 4. Okay, minus 9 B inverse into A inverse we have to do. So minus 9 by 2 into positive 4, and then you'll have to do minus 7 by 2 into negative 3. Minus 7 by 2 and negative 3. Right? Multiplied with A inverse, which is 5 minus 7 minus 2, 3. Okay. This will be coming out equal to AB whole inverse. Just check once, multiply and check. This will come out, right? This will definitely come out. Just check once if you're online. Check the result once on your own. Or if I've not made any mistake, then this will be verified very easily. But this can be a 5-mark question and you'll have to verify it like this only. Find inverse, adjoint, everything. So the steps I've told you. Just check once. I'll just be back. One mistake we have done. Sorry. This will be 87. Yeah, I was just checking. This will be 87. And so this will become minus 1 by 2. This will become minus 1 by 2, right? This will become minus 1 by 2 only, right? minus 1 by 2. Now definitely both are coming equal. When you will multiply, you can see that both sides will be equal. For matrix A, find the numbers A and B such that A square plus, this is also from your NCERT, and in sample papers also this question is there. A square plus A times A plus B times I is equal to 0. This is what you have to do. Find the value of A and B. So A square will become 3211 multiplied with 3211. Right? Simply 3, 2, 1 and 1 over here. So this will become 3 3s are 9 plus 2 into 1. 9 plus 2, 7. 9 plus 2, 11. Then 6 plus 2, 8. Then 3 plus 1, that means 4. And then 2 plus 1, that means 3. This will be your, I think, A square. This will be A square. Okay, check one, 9. Check once, 9 plus 1, hey, 9 plus 2, 11. And yeah, 9, 6 plus 2, 8, yeah, correct. 3 plus 1, 4 and 2 plus 1, 3, correct. This is A square, right? So A square, that means 11, 8, 4, 3 plus A times A. That means A times A means 3A, 2A, A and A, correct? Plus B times I. B times I means B, 0, 0, B is equal to 0. This is what is given. Right? So simply 11, this means 11 plus 3A plus B will be equal to 0. This is what is given, right? Will be equal to 0. And one more you can compare, 8 plus 2A plus 0 is equal to 0. 8, and from here you can see 8 plus 2A plus 0 is also equal to 0. So 8 plus 2A is equal to 0. This gives you A is equal to minus 8 by 4, that means minus 4. A is minus 4. If A is minus 4, this will become 11 minus 12 plus B equal to 0. So B will come out to be equal to 1. B is 1 and A is minus 4. Correct? That's it. These type of problems you can simply solve without any trouble. Here also same thing you'll have to do and find A inverse. A inverse, either if you want, you can find separately by finding adjoint and determinant. And these things you'll have to do. You'll have to find A cube, then A square, then A. So this can also be asked in a 5-mark question. This can be asked in a 5-mark question. Definitely, they can ask you in a 5-mark question. One more thing which you can do over here is, see, A cube means A into A into A. Minus 6 times A into A. Alright. Plus 5A plus 11I equal to 0. Multiply with A inverse, let's say. Multiply by A inverse. If we multiply entire thing with A inverse, right, on the right side we are multiplying. So A into A into A into A inverse minus 6 times A into A inverse plus 5 times A into A inverse plus 11 times I into A inverse equal to A inverse into 0 will be 0 only. Now here A multiplied with A inverse will give you what? I. A number multiplied with its inverse will give you I. So A square into I will become A square minus 6A into I will become minus 6A plus 5I, right, is equal to 11 plus I into any matrix. Identity matrix into any matrix will give you same matrix. So 11 into A inverse. Now take this on the right side. So I'll write this like this, minus 11 into A inverse. So here in this case you'll have to solve a little bit less. Why? Because A square you can find. A square is easier than A cube. So your A inverse will become nothing but 1 by 11, negative 1 by 11 times of A square minus 6A plus 5I. This much only you'll have to do. And this way you'll directly be able to find A inverse also. In this way you'll be directly able to find A inverse. But yeah, this you can do. This is equal to 0. Directly you can find A inverse, or if you want you can find A cube, A square, A, and then you can do however you want to do. You know both the methods now, but this can be asked in a 5-mark question. Very important MCQ. Very important MCQ. What do you think? Think about it. This is in your NCERT. This is in your NCERT, okay? This question is there in your NCERTs. And I think this, yeah, this is an objective question. We didn't discuss it till now, but this is an objective question in your NCERTs. Tell me what should be the answer of this one. Think about it. Sorry. Here you'll have to use one law. Here you'll have to use a law. If A is invertible of order 2, then what will determinant of A inverse be equal to? Here you just need to use A into A inverse is equal to I. You can start with that and you'll be able to find very easily. See, we know that A multiplied with A inverse will be equal to I. Order of I and these will be same. Now it is asking about determinant of A inverse. So we'll take determinant on both the sides. Determinant of A into A inverse is equal to determinant of I. Correct. So now determinant of I, identity matrix determinant will be equal to 1. Now we can break this determinant of A into determinant of A inverse. Okay, will be equal to 1. That means determinant of A inverse will be equal to 1 upon determinant of A. So 1 upon determinant of A will be the correct answer. Right? This is how. This can be asked in your exam also. Right? Yeah. Okay. I bought the solution. Anyway, let A be a non-singular matrix of order 3 cross 3. Then adjoint of A is equal to what? Now two things here you have to remember. Determinant of adjoint of A. Right? In this one also we have mentioned determinant of adjoint of A will be equal to determinant of A to the power n minus 1, where n is the order. Right? Determinant of adjoint of A for I'm writing it over here. I'll write below this. So you can note from here also. Here also this property is being used. Okay, determinant of adjoint of A will be determinant of A to the power n minus 1, where n is the order of matrix. Okay, I'll explain. I'll write both the things. Determinant, just write this. This is a question from your textbook only, NCERT textbook only. Determinant of adjoint of A, where A is of order n, will be equal to determinant of A to the power n minus 1. Okay. Right. And K times A, you know already, K times A, if I'm taking K out of the determinant, K to the power n will come out of the determinant and this will be, right. This I've already explained. These two things will be used in this question. A be a non-singular matrix, then determinant of adjoint of A will be determinant of A to the power n minus 1, where n is the order. What is the order here? 3. So 3 minus 1. So it will be determinant of A square. Actually, this correct answer. Remember this property, very important. In 1 mark, they can ask you this. Now, one more 5 mark question can be formed by in system of linear equation using the matrices. Solving the system of linear equation using matrix. How will you do that? For a system of linear equation in 3 variables or 2 variables, whatever it is. Generally, if they're asking in 5 marks, they'll ask you 3 variable. One question from previous year also I bought. I'll show you that. So you have 2 matrices A and B. 3 matrices A, X and B. A will be the matrix of these A1, A2, A3, B1, B2, B3 and C1, C2, C3. All the numbers, coefficients, you can say coefficients and constants. This will be A. X will be a column matrix of the 3 variables X, Y, Z. Right? And B will be the matrix of constants D1, D2, D3. Okay. Constants, coefficients. Coefficients matrix will be A. Variable column matrix will be X and constant column matrix will be B. These are written also. According to this, if AX is equal to B, we say that X is A inverse into B. Obviously, if AX is equal to B, right, if AX is equal to B, and if we multiply by A inverse on both the sides, suppose I multiply A inverse into A into X into A inverse into B. So A inverse into A will become I, that I into X will become X, and X will come out to be equal to A inverse into B. And this is what we use to solve a system of linear equation. I'll show you how. For example, this is a system of linear equation. A is given, B is given. Find BA and use this to solve. Find B into A and then use this to solve the system of linear equation, which is y plus 2z equal to 7, x minus y. So I'm writing in terms of y only. Y. Okay. All right. X minus y equal to 3 and 2x plus 3y plus 4z equal to 17. So my A will become what? What will be my A? Coefficient 0 of coefficient of x is 0 over here. Here it is 1. Here it is 2. Coefficient of y are 1, minus 1 and 3. Coefficient of z are 2, 0 and 4. This will be my matrix A. What will be my matrix X? Matrix X will be X, Y and Z. The three variables that are over here. And similarly, what will be my matrix B? Matrix B will be column matrix of the coefficients, that means constant, that means 7, 3 and 17. 7, 3 and 17. Okay. Now what am I going to do? How BA will be used to solve? I don't know how they are asking you to solve. Use BA. If we want to solve the linear equation, we know that X will be equal to A inverse into B simply. So we'll have to find A inverse and then multiply it with B. That's it. Right? You know how to find A inverse. A inverse is equal to adjoint of A divided by determinant of A. Either you can do that or you can do AX in AX is equal to B also. That way also you can do. Compare. But again, you'll have linear equations only. So it's better that we find A inverse. So cofactor matrix of A. First you'll have to find cofactor of A. That will become. So if we go element by element, cofactor matrix of A, for 0 it will be minus 4 minus 0, that means minus 4. Here the sign will change. So it will be 4 minus 0, that means 4, but it will be minus 4. For 2, it will be 3 minus minus 2, that means 3 plus 2, 5. And here the sign will remain positive only. Here, here and here. Only few places sign will change. Now for 1, cofactor matrix, cofactor will become for 1. We'll hide this 4 minus 6. So minus 2. Right? So minus 2 and sign will remain same, minus 2. Now sign will change. Sign will become plus 2. Sign will be minus into minus 2 because this position is A21. Minus 1 to the power 2 plus 1 is 3. So minus will be multiplied. Right? For this one I'm saying, if I hide this and this, what will remain? Wait. Sorry, I'm doing wrong. For this one, if I hide this and this, so 4 minus 6, that means minus 2 multiplied with minus, that means plus 2. Okay, correct. Hey, what happened there? Minus 1, for minus 1, this and this I'll hide. 0 minus 4, that means minus 4 and sign will remain positive, like same only. Here the sign will change. So for 0, if we see, it will be 0 minus 2, that means minus 2 multiplied with minus, that means plus 2. Okay. Similarly here for 3, for this 3 I'm saying, because sign will change, that's how I'm calculating earlier, 0 minus 2. So minus 2 multiplied with minus will become plus 2. Right? And for 2 it will become 0 minus minus 2, that means positive 2. And for 4 it will become 0 minus 1, that means minus 1, because sign will remain positive only here. And from here I'll simply get adjoint of A. What will be adjoint of A? Just transpose of this. That means minus 4, 5, 2 minus 4, 2, and 2 minus 4, 2, and 2, 2 minus 1, 2, 2 minus 1. Okay, this will be adjoint of A. And also we need determinant of A. What will be determinant of A? Determinant of A will need to find. So it will be 1. We'll solve row wise. From this row, if we solve 1 multiplied 0, we don't have to multiply. Minus 1 will have to multiply. Minus 1 multiplied with 4. Minus 1. This minus 1 multiplied with 4 minus 0, that means 4. So minus 4 and plus 2 multiplied with 3 minus 2, that means 3 plus 2, 5. So 10. So minus 4 plus 10, that means 6 will be the value of determinant as far as I have calculated. Now x is equal to A inverse into B. A inverse will be this determinant. What is this determinant? This determinant is 4, 2, 2. 4, 2, 2, correct only, right? Minus 4, 2, 2. Okay, and minus 4, 2. All right, minus 4, 2. And 5, 2, minus 1. 5, 2, minus 1. This matrix is my adjoint of A. This divided by determinant of A. That means this divided by 6. So we can multiply it with 1 by 6. Right? This multiplied with 1 by 6 will be equal to my x, y, and z. These will be the values. So we can directly multiply 1 by 6 to every value. Oh, sorry. X will be this. Sorry. One mistake we are doing. What did we write? We write x is equal to A inverse multiplied with B. So A inverse is this. This we'll have to multiply with B also. What was our B? B was 7, 3 and 17. 7, 3 and 17. This was our B. 7, 3 and 17. These two will have to multiply. And this will directly give us the value. The result will be a column matrix. This is 3 into 3. Right? This is 3 into 1. So finally you will get 3 into 1. Matrix that you will get will have 3 rows and 1 column. Right? You can see. So my 1 by 6 will have to multiply inside with every element. So little bit calculative, but you can do it. So I can tell you over here, simply your x will come out to be minus 4 by 6 multiplied with 7 plus minus 4 by plus 2 by 6, that means 1 by 3 multiplied with 3 plus 1 by 3 multiplied with 17. This will be the value of your x. Similarly, your y will come out to be minus 4 by 6 multiplied with 7 minus 4 by 6 multiplied with 3 plus 2 by 6 multiplied with 17. Okay, and your z will become 5 by 6 multiplied with 7 plus 2 by 6 multiplied with 3 plus or minus 1 by 6 multiplied with 17. These will be the values of your x, y, and z. This you have to calculate and finally give your answer. This is how linear equation question can also come in 7 marks. And remember, you should be solving it using this particular principle only. Use this for solving linear equation using matrices and determinants method. Okay. Use this definitely for solving determinants, solving linear equation, a pair of linear equation using matrices and determinants method. Now how could we use BA over here? B into A. Huh? Okay. BA we didn't use anywhere, right? Did we use BA anywhere? B into A we didn't use anywhere, yeah? No. Maybe some result BA is giving. That's why it's saying. Maybe B into A is giving some result. Okay, did we find the determinant? Just check all the calculations also very carefully once. Maybe there could be some mistake because it's been 3.5 hours. So now I might do a little bit of calculation mistakes. It's alright. So first one, A, if A is equal to this, find A inverse and use it to solve the following system of equations. So your A will become over here, I'm telling you, 1, coefficient of x 1, 2 and minus 2. Coefficient of y minus 2, minus 1 and minus 2. Okay, coefficient of z, z is not there, 0 over here, minus 1 over here and 1 over here. This will be your A, right? Similarly, your x determinant will be equal to x, y, z, and your B matrix will be, x matrix will be equal to x, y, z, and B matrix will be equal to nothing but 10, 8 and 7. And here also you have to use x is equal to A inverse of B. First find A inverse, multiply it with B. When you'll multiply, you'll get a column matrix of 3 into 1. That will be your x, y, z. Directly compare and give your answer. Okay. So now second question. This question is last year's only. Both were in 5 marks. So solving linear equation can come and you know how to solve it. Okay. Solve it on your own once. Please solve it on your own. Question number B was actually simple. Why? Because here you just had to do A into A inverse will be equal to I. And order of I will be 3 cross 3 because A and A inverse both are 3 cross 3. That's it. When you'll use this, you'll get your answer. We can check this. 1A2, 12x, 311. 1A2, 12x, 311. This was your A, I think, right? A inverse is also given. A1, 1A2, 12x, 311. A inverse is 1 minus 1, 1. 1 minus 1, 1. Then we have minus 8, 7, minus 5. Minus 8, 7 and minus 5. Then we have B, Y and 3. B is there, Y is there, G, 3 is there. Okay. So A into A inverse is equal to I. This should be equal to an identity matrix. That means 1, 1, 1, 0, 0, 0, 0, 0 and 0. Identity matrix of 3 cross 3. When we'll multiply and compare, we'll get the values what we require. We'll get this value A plus X and B plus Y minus B plus Y. Alright, let's do. So multiplication. 3 cross 3 into 3 cross 3, we are going to get a 3 cross 3 matrix only, right? We'll get a big matrix. Let's make a big matrix, right? 3 cross 3 matrix only we are going to get. 1 into 1 plus A into minus 8. So 1 minus 8A plus 2B. 1 minus 8A plus 2B will be this element, right? 1, 2. That means first row, second column. 1 into minus 1, minus 1. A into 7 plus 7A and 2 into Y plus 2Y. Okay, similarly here 1 into 1, 1 minus 5A plus 6, right? Similarly fill here 2 second row first column. 1 into 1 minus 16, 1 minus 16, that means minus 15 plus B into X. 1 minus 60 minus 15 plus bx. Okay, you write the other values. I'll just be back in a minute. Okay, let me check the score. We won, right? Did we or did we not? Arey Baba, tell me. Yes. Whoa, we won. We beat Australia today. I'm so happy. So, okay. Check the calculations, all of them. All right, all right. So this will become x into y. 7, 1 plus 14, so 13, minus 1 plus 14, 13 plus xy. Okay, and this is going to become 3x minus 9. All right. And now others will become minus 5 over here and plus b. So minus 5 plus b. This element, third row, second column, 3, 2. So third row, second column, minus 3 plus 7 plus 4 plus y, 4 plus y. Correct? Keep checking, all right? 4 plus y. And I think last one is coming out to because of 3 minus 5 minus 2 minus 2 plus 3, 1. Okay, this is 1. This has to come out. This 1 is equal to 1. This equal to these. So you just simple linear equations you have now. 1 minus 8a plus 2b is equal to 1. Similarly, your 13 plus xy is equal to 1. And this equation you have. Then 4 plus y. You can use this. 4 plus y is equal to 0. 4 plus y. This 4 plus y will be equal to 0. So from here y will come out to be minus 4. If y is minus 4, so 13 minus 4x is equal to 1. That means 4x is equal to 12. So x will be equal to 3. X comes out to be equal to 3. Y comes out to be equal to minus 4. Anything else? A and B, anywhere we are finding, from here, minus 15x plus b, this we can use. Minus 15 plus bx will be equal to 0. So your b, so b into x, b into 3, that means 3b will be equal to 15, b will come out to be equal to 5. We got b also. What else do we need? Do we need a? If we need, we'll put it over here. So b is 5, then this will be 10, 1 plus 10, 11 minus 8a is equal to 1. So 8a will be equal to 10 and a will be equal to 10 by 8. That means 5 by 4. These will be the values. Okay, check all the values once. There, but here 5 minus 5a. Okay, check all the values and just put these values in this equation and you can find the final value. So this is how you can solve the 5-mark questions, and in matrices and determinants 5-mark questions will be calculative. Be prepared for that. Practice these. If you don't practice, and you think that I know the concept, I'll be able to do in the exam, you won't be. Marks can be lost in matrices and determinants due to calculation. So practice this. Mark my words. Practice matrix and determinants. Don't forget to practice. Okay. Now tomorrow. Okay. Arey, B is 5, correct? 5 minus 5a, where 5 minus 5a is equal to 0. 6 minus 5a. Arey, 7 minus 5a is equal to 0. So a 7 minus 5a is equal to 0. So a will be equal to 7 by 5, not 8 by 5. Something contradictory is happening. Just check the calculations one, and you have the solution also. I'm not sure that the solution is entirely correct, but yeah. Okay, this is the way you can solve it. Now practice this. Okay, practice of matrices and determinant. Tomorrow we will do calculus. Calculus will not, it's a big chapter, 5 units are there inside calculus, but tomorrow we'll do calculus. But I'm saying calculus is big chapter. Okay, so I'll bring important questions and related concepts to them. Okay, today we have taken almost around 4 hours, but I'll try that I don't stretch, because I know your time is important right now. You cannot give that much of time. You have to practice yourself and prepare yourself also. So I'm just trying to bring up important question and important concepts which can come in your 12th board exam. Tomorrow I'll do the same with calculus, applications of derivatives, application of integrals, definite integrals, simple integration, and continuity and differentiability. These are the 5 units, right? So we'll do that tomorrow, and after that we'll do vector algebra, linear programming, and probability. Okay, linear programming is also important. 5-mark question are asked from that, so don't forget linear programming, which is a very easy chapter. I'll teach you tomorrow or day after tomorrow as soon as I can. Today I'll take my leave, and so that's all for you. Okay, bye bye, take care, thank you. Don't forget to hit the like button if you have come on the session. Once again I'm telling, and the starting slide, if you have seen, I've shown the link for the important batches which are going to start on Unacademy for class 11, class 12 and droppers is there in the link, is there in the description. So hit on that and do appear for that.